Hello everybody and welcome to another video in which I'm going to attempt some puzzles that somebody else received as a gift in the Secret Solver 2023 event, which is a puzzle event where the 70 participants, in my last video I said maybe 60, it turns out it's 70 people who signed up, and everyone makes a puzzle for one other person, forming a cycle. This is the set of puzzles that was made for Penzo. In other words, Penzo is the name of the recipient. But I'm going to attempt these puzzles myself. Penzo has already solved them. And I have already looked at the first one, the artistic task, so I already have a vague idea of the mechanic there. All the other ones I'll go in blind. So let's get started. The artistic task. Paint a picture of your choosing. Your time starts now. Okay, so this your time starts now as well as the seal here reminds me of the British television show Taskmaster. So I expect that to become relevant, but I don't think it's relevant in this particular puzzle. So I think it will become relevant in the final task of the show because it says of the show. So I assume that the show is relevant there. So here we have a set of sentences. First, I thought I would try painting a piece of formal wear, but I was worried that I would accidentally paint a rowing enthusiast instead. I don't know what's up with that, but I've looked at the other sentences and they're all of this sort of general scheme. Try painting something, and then I was worried or afraid, or I might unwittingly paint something else instead. They all end with the word instead. So I'm going to break these sentences apart into their two constituent pieces. I think that if we just end with the word painting each time, then we probably get the start of the first part. So the painting somewhere for flowers to grow. I wanted to paint, so it goes up to here. To paint goes here, paint, and then painting, paint, and painting. Right, and then comma, but, and then I'm gonna have to, remove stuff like I was worried that something instead. So I'm going to do that manually. This one here, a distrustful person, the possibility of painting a subtle detail, that, a country, a book, a hook, a trendy superfood, a herb, and a textile pattern, and then finally a dishonest, no, it's someone who had obtained a dishonest advantage, and then we'll just remove the word instead at the end. Okay, now I'm going to put this in a spreadsheet. Here we go, and I'm going to put two columns in between, one for each answer here. So these are the first parts and these are the second parts. Alright, so let me just make this a bit bigger so that it's easier to read on the stream, but also it's nicer. Let's use a font that is also nicer. Okay, here we go. So I'm going to have to figure these out. Now the one that I've already figured out, which tells me what the mechanic is this one here. So for the French River, I thought of three very famous ones. There is the Seine, there is the Loire, and there is the Rhône. But I believe that in this case it's the Seine, because the part of a book, I messed this up. It shouldn't say a book. It should say part of a book. That is actually the spine. So let's right align this. And then over here, I'm going to say one of them has an E where the other one has a P. And let's center that. So I think that that is basically how this will go, that one of these is going to be one letter away from the other one. So someone with children could be a parent. Oh, Intellectual property rights. So when I was reading through this, the first time I was thinking of copyright and trademarks, but I didn't think of patents, which is of course also a form of intellectual property exploitation. So R and T. Let's see, a rowing enthusiast, I would say, is a rower. A piece of formal wear could be a suit. So if it's suit, let's see, a rowing enthusiast. Skit? No. It's possible that that might be a word that I don't know. A pronic number, I actually looked this up. A pronic number is the product of two consecutive integers. So for example, 2 times 3 is 6, so 6 is a pronic number. They're also called oblong numbers, heteromessic numbers, or rectangular numbers. Yeah. Okay, so the first few, okay, so this is 0 times 1, 1 times 2, 2 times 3, 3 times 4, etc. Okay, so we're probably looking at the English word for such a number. So it's either 0, 2, 6, 12, 0, 2, 6, 12, maybe 20. And then one of these words will be one letter away from something meaning a subtle detail. A subtle detail, so I'm thinking like a nitpick or a nuance. For once, your stream doesn't give me the unexpected error. Cool. I'm glad to hear that my stream is working. It's definitely an interesting puzzle, I agree. A famous civil engineer. Who could be famous enough to be guessable? 12 of the greatest civil engineers of all time. Let's see if one of these, bingo, right, the first one, Brunel, is one letter away from the country of Brunei. So I'm gonna assume that it's that one, but let me just quickly look through the rest of them. John Smeaton, that is definitely not one letter away from a country. Eiffel, the Eiffel Tower fame. Jesus, that took me ages to say. So Gustave Eiffel is the architect of the Eiffel Tower. Also not one letter away from a country. Bradfield, I don't think. Damascus, of course not. Bazalgette, also not it. And Whipple. Stevenson. That would surprise me a lot if there were a country I'd never heard of that was one letter away from that. Rennie, I don't think that is a country either. Buchanan. Is she related to the US President Buchanan? It doesn't say, but who cares? Telford. Okay, so I'm gonna, because this one stuck out to me immediately and none of the other ones jumped out at me, so I'm gonna assume that this is the one. Okay, somewhere for flowers to grow. That could be a meadow, or as crossword puzzles often like to call it, maybe a lea. Metapod's favorite move. Now, Metapod sounds like it could be a Pokemon. In fact, it is a Pokemon because I've already looked it up earlier. And on this page, I see that the moves that it has include... Here we have something called usable max moves. We have max lightning, max guard, and then we have some other things here. Harden, bug bite, and string shot. Okay, let's close this page. Let's see, we're looking for something that is somewhere for flowers to grow. Somewhere for flowers, a garden. Okay, harden and garden, that will work. Let's assume that this is the intended set of words. A workers' protest is almost certainly a strike. A hook-billed bird, well, that sounds like a toucan or something, but one letter away from strike. I'm fairly confident with strike here. What else would a workers' protest be? So I'm going to try and solve this with Nutramatic by just saying that one of these letters has to be different. And let's ask Nutramatic to see if it comes up with a word. A stripe, strife. Okay, so stripe and strife mean other things, but maybe they also mean a hook-billed bird. Strife, let's see. That... Oh, there we go. No, we do not. Oh, sorry, I misread this. For some reason, I thought this said something about bird, but no. There is no bird here. So let's try the other one, stripe. I have less confidence with this one. Is that a bird? It's a billiard ball. Okay, that makes sense, because some of them are striped and some of them are solids. But I'm not seeing anything with a bird. What about shrike? That sounds like it could be a bird. Oh, there we go. That is a family of birds. And the bill does look a bit hooked, so I'm gonna assume that this is what they want. What does it say? A hook-billed bird. Is there a close-up? Oh, that is definitely hook-billed. There you go. And that fits the description, so we're gonna go with strike and shrike. And that is a T and an H. This seems like it will form an English word. Maybe this one will as well. A trendy superfood. The only one I know of, again from crosswords, is this berry, acai. And that word itself is of Portuguese origin. So maybe the Portuguese estate will be one letter away. Let's see. Okay, so this is obviously not helping. Let's look at a crossword solver and see if that can give me a result for this. Quinta, especially one in the countryside. Okay, quinta, that sounds like quinoa. Yes, there you go. Quinoa is a trendy superfood, and we have a T and an O. A snooker player's action. This is another one that I've already figured out before looking, because Max Park is actually a speed Rubik's Cube solver, so he likes cubing. So that's an E and a B. Now a textile pattern I thought of two, namely argyle and tartan, but I couldn't find one that is one letter away from a herb that I know. So I'm gonna have to... Unfortunately, there are a lot of herbs that are like very short words, you know, like sage, for example, and well, let's just write down as many as I can think of. We've got thyme, we've got pepper, not pepper, we've got rosemary, parsley, sage, rosemary, and thyme, so parsley is another one. Parsley feels like it could be a candidate. Maybe parcelet or something as a textile pattern. So let's use the same strategy that I used with the other word and ask Nutramatic. It turns out paisley is, let's go images, there we go, that is a textile pattern, and it says design, ornament, textile design. Okay, my instinct was right that it is parsley, despite me never having heard of paisley, but you know, it just sounds sort of designy. I don't know why it speaks to me in that dimension. Something that might contain treasure is almost certainly a chest, and someone who had obtained a dishonest advantage is a cheat. That one was easy. Okay, we have a phobia here. Tachyphobia? Oh, tachyphobia. Isn't that harking back to my time in Catane? I believe that no, it's tachyphrasia and taphophobia. Okay, let's not do that. Oh, taphophobia. Okay, this is an I instead of an E. So whatever. Let's see if we can. There's also letters here. There could be ring letters, maybe. We'll find out. Someone with children. Okay, we've got that. A piece of formal wear. Let's see what synonyms there are. No, not one look. I want this. Thesaurus. This will find me some clothes. A ball, a gown. Okay. Okay, so that could be a gown, a coat, a suit. A rowing enthusiast. Okay, maybe there is a crossword clue for that. Let's see about rower, oarsman, boatsman, oarsman. So I can think of one person in a rowing boat, especially in Olympic rowing, and that is the cox, which is short for coxswain, which I think is spelled like this. But that's not one letter away from coat, it's two letters. So it's probably not that. If it were a piece of rowing equipment, then I could say coat and boat. But it's not going to be boat because this here needs to have a letter. Oh, I said ring letters earlier. I completely neglected that there is another letter in front. So maybe, I don't know, crang letters, tring letters. I don't know. Oh, bring letters into order. No, I don't know. Okay, we need to figure out some more. A quadratic curve. I believe that is called a hyperbola. Let me just quickly check that, because if it turns out it's a parabola, then let's see. This will probably tell me, is it a parabola? It is a parabola. Let's see what a hyperbola is then. A hyperbola is a type of smooth curve line in a plane, blah blah. The other conic sections are the parabola and the ellipse. Well, here we go. This is definitely not a quadratic, is it? This one here looks very much like the function x squared plus 1. Oh, here we go. The graph of a quadratic function is a parabola. Okay, it is a parabola, which means that oh, wait a second. The distrustful person is paranoid. Paranoid. It's parabolic? Paraboic? I think it has something to do with paranoia. Let's okay, if I do paranoid and I do this. So actually, let's say it's either paranoid or paranoid. There you go. This will, whoops, let's, interesting, it doesn't let me do backspace. Okay, it does now. Okay, let's change these to pipes and let's ask Nutrimatic if there's something starting with para B, and there isn't. Okay, maybe. Okay, let's see where the quadratic curve. It just says a quadratic curve rather than the shape of a quadratic curve, so it would be parabola. I thought I might end up painting a distrustful person, not relating to a distrustful person. Okay, so in that case, let's try parabola. And let's change one letter from those. None of these ring a bell. This sounds like it's a parasol. Oh, it's a fungus. Okay, that works too. I suppose they're in the shape of a parasol. But that doesn't tell me about the distrustful person. I have a suspicion that it's still something like parabolic and paranoid. Let me just see if parabolic is actually a word. No, it tells me it should be parabolic. What about paranolic? Is that a word? No, it's just saying it should be parabolic. Paranoic? Paranoia. Okay. So I'm really not sure about this, but I suspect that the letter changing is probably this one. This is weird. Okay, so what about this one here? We still haven't looked at this, the subtle detail. Let's see if I can find a synonym for detail. Minutiae, triviality. By the way, if any of you in the chat have an idea for what the the quadratic curve and the distrustful person could be, please feel free to chime in. I'm okay with that. So what am I looking for again? 0, 2, 6, 12, or 20? 0, 6, 12. I'm not seeing it. 20. Let's see if there is more. Yeah, these are verbs. I'm probably not looking for verbs because a subtle detail, that's not a verb. Okay. 0. Is anything here similar to 0? No. Is anything similar to 12 or 20? It would have to start with TW, or the TW is the one that changes. So, I don't know, 20? You know what? I'm going to use Nutramatic again. I think it's probably one of these two. It's either 12 or 20. So let's start with 12 and then we add 20. There we go. Remove that and do this. Let's see if Nutramatic can help us with this. We get a 20. Yeah, that is a region in the Netherlands. It's not something about details. Tweety is also not it. So, let's try the other words then. What was it? 0, 2, and 6. 0, 2, and 6. This is going to come back with a lot of possible words. You know, like for example, this alone is going to be like fix, mix, lots of stuff. But hopefully we can find something. Okay, hero is an interesting word that is one letter away from 0, but it still doesn't mean a subtle detail. Let's see, what else could it be? A subtle detail. A Xeno. Don't think it's that. Yeah, that's just a person's name. Okay. Kind of stuck here, so if anyone has any ideas, feel free to chime in. Let's see what this here has to say if I type in subtle detail. Nicety. That is 90. Oh, 90. That is 9 times 7. Nicety and 90. We have it. Okay. Quadratic curve can also be a hyperbola or something. Whoops. Let's open this. Let's put this here and let's close my emails. Not sure what the other can be. Well, from hyperbola there is hyperbole, which means exaggeration. But okay, thanks for the clue. I guess I'm going to try hyperbola after all. Let's see if that gives us something. Nutramatic, here we go. Yeah, that's what I suspected. It'll just give me hyperbole, and that just means a figure of speech in which exaggeration is used for emphasis. So that is not a distrustful person. Let's see if this can find me something under distrustful. A cynic, a conic and a cynic. Oh wow, that is sudden discovery here. Okay, so we have N and C. So wrong letter, right? These are the wrong letters, and we want something TICHI and then phobia. Let's see if Nutramatic can tell me what that missing letter is, and if not that, then maybe this one. Atachyphobia, the fear of failure. Okay, I'm gonna say that's an A, so let's see if Goan, G-O-A-N, you know, now I'm already on Wiktionary, so why don't I look it up here? That does not mean a rowing enthusiast. So maybe it's not, it could be something like a waistcoat, Okay, formalware. Let's just Google for this. A list of formalware. Click. Okay, let's take a look. Let's see if we have a list here. I guess we can use this. There's the word gown again. Yeah, it would have to have a W in it. So let's highlight those. A bow tie. A bow tee! There we go. It's a bow tie versus a bow tee. Nice. Okay. I believe that we have completely finished this puzzle, so I'm quickly going to go over to the answer checker. I'm going to type in Atticophobia. This. It is correct. Okay, ladies and gentlemen, we have our first correct answer. The Tasks of Penzo. 12 plus 1 Tasks of Penzo. Yep. So I'm going to abbreviate this to just artistic so that the names of the tabs don't get too long. And then we're gonna put the meta here. And we're gonna say that artistic. The answer was this in one word. There you go. So I'm going to make this very big because this doesn't need a lot of space. Let's give these a nice font, like I guess bitter, the same one that we had earlier. Make it bold. And this one here, my favorite answer font is Montserrat. We have, oh, neat, kayaker. Not a bad guess. Okay, so I received a ping on Discord, so I'm quickly going to check on my phone what that was, just in case it is actually Penzo. Okay, it was Penzo, and he is telling us that he will join us later, which is totally fine, because so far we're not stuck, but, you know, if I need a hint later, then I'm gonna, like, you know, write down the hint requests, and then when Penzo joins us, he'll be able to give us hints. Now, the balancing task, let's move on to that. Let's make a tab for that, put it here, and take a look. Use the weighted shapes to balance the apparatus. What is the name of the physical law that relates the distance from the fulcrum, or from the pivot, with the weight? 1, 2, 3. Okay, so these are the same distance, right? So that means that the weight on this vertical line needs to be exactly 8 kilograms, which means, yeah, okay, so physics, formula, fulcrum, and lever, I think is what it's called. Fulcrum calculator. Okay, so bingo, that is exactly what I'm looking for. So FE and DE, so this is the force down here. That times the distance from the fulcrum is equal to that force times that distance. Okay, so that means that we have, let's see, okay, I'm going to write down all the shapes. We have a circle, we have a triangle, we have a, what is this? That is a heptagon, not a help. What a typo. 2, 4, 6, 7, that is a heptagon. Then we have a square, and that is a nonagon, isn't it? 2, 4, 6, 8, 9, yes. Then here we have an octagon, we have a hexagon, and we have a pentagon. Okay, so it seems that none of the non-given shapes repeat. I for some reason, without even looking at the page, I assumed that we're going to have multiple, like for example, multiple triangles, and that they have to be the same weight. But no. So here we just have a formula, right? We have that the triangle times 3 needs to be non-givenagons. So I'm just thinking that actually It needs to balance the entire apparatus. Oh, this is how we do it. Okay, so 3 times the triangle is equal to the, what is this, the heptagon. So I'm going to rename these. I'm going to rename these to P and then the number of sides. So the triangle is P3, the heptagon is P7, right? But then we also know that P3 plus P7 needs to be equal to 8, right? Because it needs to... Wait, no. Ooh, this is interesting. Okay, so what's actually going on here is that 19 times 3 is equal to, well, the total weight of these. So that's P3 plus P7 plus, and then 1, 2, 3 times 11. Now, obviously, 19 times 3 minus 3 times 11 is simply 24. So I can just make that 24 and that's 0. So now we know that P3 plus P7 is actually 24 and not 8. Okay, so that means that P3 is 24 minus P7, which means that we can plug that in here. We have 24 minus P7. Let's multiply that out. We have 72 minus 3 times P7 equals P7. Let's move the 3 times P7 over to the other side. We get this. So we need to divide this by 4, and we get 18. So P7 is 18. That is our first result. And then, of course, 24 minus 18 is 6. So P3 is equal to 6. Okay, so I suspect that we're going to end up with values between 1 and 26, and it's going to read out a word in the order of the number of sides per thing. Okay, so this was the easier side, right? We now need to... I suspect that this entire thing here is going to create a system of linear equations, which I could, if I wanted to, just run through Maple or some other automatic solver. But because I enjoy this kind of process, I'm going to do it all by hand. So, we already know that the total weight of all of this here, I'm going to call this the right-hand side, so R. So we have 3 times R. No, I'm not going to call it R, because I'm going to write it out. And the total weight of this is, of course, 19 plus 11 plus 6 plus 18. So there we go. So that is, I am going to call it R, actually. So that's that. And then we know that 3 times R needs to be equal to 2 times L, the left side here. Okay. Which means 162 times 3 is that, and then divide that by 2. So L is equal to that. So I guess we don't really need R anymore, do we? I'm just going to assume that my calculation for L is correct. If it is wrong, then we'll just get nonsense answers and I'll just do it all over. Okay. So, let's see. Okay, so what do we have on this line here? We have the square, which I decided to call P4, times 4, plus this one, this point here. Since I called this one L, I'm going to call this LL, is equal to 1, 2, 3, 4, 5 times LR. Okay. Okay. And then this one here, LL, is the sum of all of these weights. So that would be P, 2, 3, 4, 5, 6, 7, 8, 9. P9 plus 2 plus P8. Let's put that in a sensible order. So 2 plus, let's do that. There you go. 2 plus P8 plus P9. But at the same time, P9 times 1, 2, 3, 4, 5 is equal to 2 plus 3 times P8. So these two equations relate P8 and P9 in terms of LL. So I can probably... Yeah, I could use this to write P8 and P9 in terms of LL. But let me write down all of the equations first. So this one here I called LR. Right, so LR is of course the sum of all of these weights, which is 9 plus the hexagon, which is P6, and then the pentagon, which is P5. At the same time, 1, 2, 3, 4, 5 times 9, which is of course 45, I didn't even need to write that out, is equal to 3 times this bit here. Now, I called this one LR, so I'm just going to call this... No, I'm not going to call it LRR. It's simply the sum of those two. It's just P5 plus P6. And then finally, P5 is equal to 1, 2, 3, 4 times P6. So with these three equations, we can find P5 and P6 in terms of LR. And then we can plug that in here. This one here is the only equation that involves P4. Oh, that's right. There is another way. Right, okay, so this is actually the same as P4 plus LL plus LR. Bingo. And L, of course, is this. So I guess I don't really need to write L as a separate equation anymore. Okay, I think I have all of the equations, so I'm going to make this bigger. Let's just put this here so you can still see the diagram. And now let's do some transmogrification of equations. Let's see. I'm just scanning this to see if there is an easy way. Okay, let's actually start with this here. Okay, so we know that P5 is equal to 4 times P6. So I'm actually just going to plug that in here. And then I'm going to multiply out the 3. So that becomes a 12 and that becomes a 3. And now you can see that 12 plus 3 is actually 15. So P6 is equal to 3. And since P6 is equal to 3, that means that P5 is equal to 12. Now if P5 is 12 and P6 is 3, then okay, I have a confirmation that I'm on the right track. This is a 12 and this is a 3. So LR is 24, which means that I can plug that in here. And that is equal to 120. Okay, I don't think I will need this again, but just in case, I'll put it here. Let's see, what else do we have? This is a system of equations. No, we actually need all 4 of these equations. We have 4 equations and 4 variables, P4, P8, P9, and LL. Right, those are the variables we need to deal with. So let's continue here. I'm going to say that P9 is all of this divided by 5, and I'm going to put that here. Okay, and let's multiply this out. So this is going to be 2 over 5 plus 3 over 5 times P8, plus this P8, that would be 5 over 5, so that makes it 8 over 5. And then this would be 10 over 5, which makes this 12 over 5. Okay, so here we have a formula for LL, which I can plug in here. Okay, this is the equation that we just used, so I should probably get rid of that. So we have LL in terms of P8, so I guess I can put that in here. I'm not sure if this is super helpful, but let's just try this. Let's multiply the entire equation by 5, just to remain in the realm of integers. So this would be 600. And I guess at this point we can divide by 4. Yeah, let's actually subtract 12 first. So we get this. Okay, and then we can divide everything by 4. And then 588 divided by 4, that is 147. Okay, so that is an equation that relates P4 and P8. then I can, okay, these two are the same equation, right? And I've already used that. Am I blind? Because are those two equations the same? No, they're not the same. I have two equations in P4 and LL. I should be using that. There we go. So let's start with this. Let's continue with this rather. So LL is actually 120 minus this. And then we can plug that in here. So 120 plus 24 is 144, not 1000 or something. Then P4 minus 4P4 is minus 3P4. Let's put the 243 on the right hand side, so that actually becomes negative 99. And I seem to have made a mistake because I'm getting a negative number for P4 there. So did anyone spot my mistake? If so, please speak up now, but I'm going to try this again. I'm just going to do the exact same thing again. But I'm going to use a different strategy. First of all, let's rearrange this equation. Let's subtract the 24. That would give 19. Okay, and now we can subtract those two equations, and we get negative 3 times P4 is equal to this, which is positive. So again, I'm getting a negative number. So I think I made a mistake somewhere. But now I have some experience with this, so I should probably, you know, maybe I can just verify these equations. So we have LL, which is this point here. Let's look at this one here, right? This is 1, 2, 3. This should have been a 3. Yeah, that should have been a 3. That doesn't quite make a huge difference, but okay, I'm going to assume that these numbers are correct, and I'm going to start over with the rest. So we have 3 and 7, those are on the right-hand side, and 5 and 6, that's those two here. So I'm going to calculate this here, this point here, that is equal to P5 plus P6, which is 15. And then we need 3 times that to be equal to 1, 2, 3, 4, 5. 5 times 9. And it does equal. So I believe that those two are correct. So that means that this here, LR, is equal to 9 plus 3 plus 12, which is 24. Okay, and we need 1, 2, 3, 4, 5. 5 times LR to be equal to all of this, which is, that does P9, isn't it? Plus 2 plus P8. We need that plus 1, 2, 3, 4. 4 times P4. Okay, so that is that equation. Now, obviously, I can plug in LR because I know what it is. It's 120. I can subtract the 2, so that becomes 118. And then we have this equation relating 3 unknowns. What else do we know? We know that, yeah, we know this point here needs to equal, yeah, okay, so 2 times LL is equal to 3 times, sorry, not LL, I meant L. And R is, of course, 19 plus 11 plus P3 plus P, 1, 2, 3, 4, 5, 6, 7, P7, that's 18. Okay, so that is equal to this. Divide that by 2, and we get L is equal to 81. I don't know if that is the value I had earlier. And then we need 3 times that to be equal to 2 times, did I just, I think I meant R here, didn't I? I just added up 19, 11, okay, what, am I really this bad? I need to undo to, oh, I see, no, it is L that I wanted, no, it is correct, So, and we got that by doing this balancing, because I'm so bad at remembering what. So now we know that L is 81, which is simultaneously equal to P4 plus plus this one here, which is P9, plus the 2, plus the P8, plus this point here, which we already know to be 24. So I believe that this is another equation that relates P4, P8, and P9. And I'm going to subtract the 24 and the 2, which gives us 55. 55 is equal to this. There you go. Now I can subtract those two equations. I get 63 on the left side, and I get 3 times P4 on the right side. So P4 is actually 21. Okay. So now that we know P4, which is this one here, we should be able to... okay, so this is LR, which is 24, right? So we know that 1, 2, 3, 4, 5 times the 24, which is 120, is equal to all of this, 2 plus P8 plus P9, plus 1, 2, 3, 4 times P4. Now we've already discovered P4, that's 21, which means that we can do this, we can add the 2. So that would be 86. And then let's subtract that from the 120, and that is 34 for those two together. I could have just subtracted P4 from this. Let's just make sure that that is in fact, yeah, that gives us the same answer. Okay, so that was a bit embarrassing. We don't need that anymore. We have this now. And now we need another equation that relates P8 and P9, and that equation is that this needs to be balanced, right? So 1, 2, 3, 4, 5 times P9 is equal to 2 plus 3 times P8. Okay, so we can put the P8 on the other side here, make that a minus, and then we can put that in, no, we put that in here, where P9 is equal to that. And now let's multiply that out. We get 170 minus 5 times P8 is equal to 2 plus 3 times P8. We're going to put that 3 times P8 on the other side, so we get negative 8. This is looking good, because 2 minus 170 is now that. So we're just doing that, and now we just divide this by negative 8. I'm doing all these steps with all the negatives just so you can see exactly what I'm doing, but the end result is that P8 is equal to this. So we have FULCRU. And I forgot about P9, which therefore is obviously an M. So 34 minus 21, that is indeed a 13. So I claim that the answer is fulcrum. And fulcrum is correct. So I didn't need a tab for this. So I'm just going to delete that tab. Okay. But I am going to put it here, balancing fulcrum. This is a very, very cool mini hunt. It is you know, reasonably simple and approachable puzzles. I'm not stuck yet. I am enjoying this. Let's go back to the list of tasks. We have the illumination task. This looks like an Akari. Light up the room, your time starts now. Okay, pen power plus, that is convenient, thank you. Let's hide the timer. Okay, we have a standard Akari puzzle where looks to be non-trivial to find a break-in. None of the numbers are 3s or even 4s, that would have been easy. I suspect that this one here will be a contradiction. Can I do this? Okay, let's do this. So if this is on, not only would all of these be off, but crucially those will be off, which forces this 2 to be that. And then we get this and this. That does not look like a contradiction yet. Because the 2 could be either one of these. So maybe that is not actually a contradiction like I thought it would be. Where else could I try and look for contradictions? So, in general, right, if you put Oh, there we go. This is impossible because it rules out both of those, and then the 2 would have to be satisfied like this, and then the 1 is violated. So that is a no-go. The same should therefore apply here, because if this is on, it does that and violates the 1, so that is a no. This one, because if this is on, then that is violated. So that's off. Let's see. That is all of the 2 and 1 next to one another. Okay, let's think about some more. If we have one here that would rule out those and mandate those, and then this would be impossible, and then the 2 would have to be like this, and that satisfies the 1, and then you get all of this, and then this 2 here is forced, and then this 1 is satisfied, this 2 is forced. I'm in a huge hypothesis right now. I hope that isn't going to bite me. That line needs to go all the way. So it seems to me at the moment that everything is satisfied. So what was my hypothesis? I hope I didn't lose track. Okay, I think my hypothesis was, no, that's it. This was my hypothesis. So let's do the alternative. Let's say this is on. Then this 2 would have, oh, bingo. You can't have that. So that is off, and everything that I just did was actually required. So that goes here, that goes here. That 2 is now forced, so that goes here, that goes here. That 2 is, that 2 is forced, like this. That 1 is now satisfied. Okay, so this 1 needs to be either here or here, so that is off, but also because that 1 is satisfied, so either way. That 2 is forced, so both of those are on. That 1 is now satisfied. This 2 is now forced like this. And now there's only one way, no, there are 2 ways to illuminate this square. It's either this or this. Yeah, so for as long as there are 2 possibilities, let's move on to something else. This could still be illuminated from down here, and either one of these 2 illuminates the other. So I cannot determine that yet. This 1 is either here or here, so that's off, but that doesn't really help much. Okay, let's see, that 1 is satisfied. So what happens if I put a light here? Because then the 1 is satisfied, so we need this to illuminate that. And then, and then all of this is green. That doesn't force anything. Doesn't even force this to be on because it could be illuminated from here. So that is not... So yeah, this was my hypothesis. What about the alternative, which is this? If that's a light, then that is off. Does that force anything? It doesn't seem to me like it does immediately. So let's undo that as well, and let's take a look at some other hypotheses that we can run. For example, we could put a light here, but that wouldn't really force anything either. The ones aren't really all that helpful. I need to find a way to make them helpful. So what happens if... Yeah, I was gonna say what happens if I put a light here, and it does seem to imply a lot of things, especially this one here, but even if that's a contradiction, it only gives me that, which is not much. So it's not even worth exploring that. So I'm gonna try something else. I'm gonna try this. If that is a light, It satisfies all of these ones, and it forces this, which forces this too. And then, oops, and then these are all done, and then it forces that. So this 2 still needs a light, so this is not the light. But this square needs to be illuminated, and that is the only way to do that. So that happens, but now this square needs to be illuminated, and the only way to do that is to put a light here. And now this square can only be illuminated by itself, and then that. I suspect that I may have run into the correct answer by accident. Yeah, isn't this a viable solution if I put one in either of those 2 places? What am I missing? Oh, I have to illuminate this square, so it would have to be this one. But I've probably missed something. There's probably a square now that is not illuminated, and I found it. It's this one here. Yeah, so I made a mistake by using green to mean both already illuminated and can't be a light bulb. I make that mistake a lot in Akari, so I'm going to have to use 3 different colors for this. And I believe that, yeah, I can use the letter keys to switch between colors. So I'm going to use that. I'm going to say red is not a light bulb and green is already illuminated. So where did I start? I started, yeah, okay, so these would have to all be red. Okay, I do want to do this properly. So if this were red, the right click will always do green. Okay, so if this is illuminated like this, and it forces this, and it violates the 1. Therefore, this is not a light bulb, but it still needs to be illuminated, which is why I'm making it red. Okay, so the same applies to here and to here. And then what was my next reasoning? I think I hypothesized, what if this is a light, and then all of this, and then it forces these, and then these are satisfied. Ah, see, again, I made that mistake. They are satisfied means they can't be light bulbs, but they still need to be illuminated. Okay, but this is not a contradiction, is it? I'm not seeing a contradiction here, so I should have remembered what my next deduction was after this. Was it this? If that is a light, then it forces those to be lights, and then these can no longer be lights, but this is now green. This 2 is now forced, which illuminates these, and these, and these, and this, and this. And the 1 is now satisfied, which means that this is not a light bulb. And now, the only way to illuminate this space here is to put a light bulb here. I think I am still inside a hypothesis, aren't I? The hypothesis being this light bulb here. God, this is difficult. This is... no, it's not difficult. It's me being unable to keep track of what I've already deduced. So let's see. So that 1 is satisfied. This 2 is now forced. I'm just gonna go with this hypothesis. If it works and if I find the right answer, then that's it. So, let's see. So this 2 requires those 2 to be lit, which does all of this. And now this 1 is satisfied, so these cannot be light bulbs, but they still need to be lit. Now one of these is a light bulb, so this one is not. That's not a really helpful deduction, is it? So the only way now to illuminate this red space is to place a light bulb here, isn't it? There is no other place to put it, so that goes here. Okay, so this one has to have its light bulb either here or here, which means that this is not a light bulb, which means that either one or both of these has to be a light bulb, so that is not. Let's see. I still need to illuminate this square. If I put a light bulb here, then I will also get a light bulb here. But I could also put one here and that will illuminate all of that. Does that create a contradiction? Because if I put a light bulb here, then this cannot be a light bulb, but lots of other places here can still be light bulbs. By the way, I can tell now that this is going to spell out answer. I'm going to use this side channel deduction. I'm sorry, I'm kind of cheating a little, but the fact that this spells out answer strongly implies to me, okay, so this cannot be a light bulb because the one already has one, but we do need to illuminate it, and the only way to do that is to put one here, which satisfies this one. And now the only way to illuminate this square is to put one here. So that's done. And now the one is satisfied, which means that neither of these can be light bulbs, which means that the only way to highlight this square now is to put a bulb there. So these are green. Also, this one is satisfied. Yeah, this one here. This one still needs a bulb. That has to go here, which forces this. And we still need to illuminate this square, which can be done either here or here. Now that this too has a bulb next to it, it's effectively a 1. So if I were to put a light bulb here, it would force this 2 to have both of those, and that violates the 2. Therefore, this is not a light bulb. And now the only way to illuminate this square is to put a light bulb here, which satisfies this too. So these are not light bulbs. So that too can only be satisfied with a light bulb down here. And then we need one here. So it says answer under the spotlight. Under the spotlight. Okay, let's see if that is the answer. Yep, I misspelled that. Under. Bingo. Under the spotlight is correct. We have our third puzzle solved. It was the illumination task. Illumination under the spotlight. There you go. Let's make that a bit bigger and that a bit bigger. Very cool hunt so far. Okay, the image recognition task. Let's see how much Google we need for this. Help an AI identify these images. Your time starts. I think this is someone getting married. 60% certainty. Okay, the hot finish room is obviously a sauna, which is kind of like sauce. So maybe this is another sort of letters off of things. So I'm going to make a spreadsheet for this. It's called the image recognition task. So let's move to this here and do this. This is image recognition. Have there been any more messages? No, that is fine. You're all just watching me in awe. No, I'm kidding. Okay, let's put bitter here. So I think someone getting married. Okay, let's actually, you know what? I'm going to open this in Chrome, because Chrome has this nice feature where you can right-click and search image with Google. So this is obviously an X-Acto knife, which you know, it doesn't find the name of it here because in Germany this is not the brand name we use, but I'm going to assume that X-Acto is supposed to be the thing. So Let's insert a row above. These are the images. So I think that's an X-Acto knife. Now let's try the next one after. Why did I do that? I want to do this. Search image with Google. That is a Comic-Con. It's at Comic-Con. Okay. Let's assume that it is in fact Comic-Con. This one here seems to have multiple elements on it. It seems that this red cart is probably photoshopped into it. Or maybe not. The crofting system, countercurrents. What the heck is going on here? Crofter. Croft. Okay, so it's either croft or crofter. Or croft house. That is not photoshopped. That is actually there. Interesting. So let's take a look at what this is. Ooh, there is actually no English language link for this. But let's just see what English Wikipedia says. If I go there, it redirects to croft. Okay, so it's probably croft. The next image after that is inflated. And then the next one, that is an, I'm gonna say pride flag. It could be LGBTQ, it could be lots of other things. This looks like a recorder. It is a soprano recorder or an alto recorder. Yeah, Google can't even make up its mind what kind of recorder, but I'm just gonna put recorder. I just noticed that these are alphabetical, so it's not actually X-Acto. So I'm gonna come back to that later. This is obviously a source. Okay, yeah, I think it's just hinting at general source, right? The exact image is gonna be of a specific source, but okay, pizza sauce, barbecue sauce. Yeah, let's just assume that they just want sauce. It does fit alphabetically, right? Bolognese would not fit alphabetically. And then we have this one here. This is stacking. This is cup stacking, but you know, cup is not alphabetical, so I'm gonna assume it's stacking. Sport stacking. Okay, it could be sport stacking. Okay, and now let's go back to this. So I said exact. Oh, maybe it's actually just, yeah, it's the blade. It's not the knife itself, it's just the blade. Okay, let's say that is a blade. Now, someone getting married is a bride. Blade, thank you. Yeah, thank you for your help. I got it before you, Nina. We have a bride. So bride is very likely intended to be 2 letters away. So LA becomes RI. Someone who's extremely hungry. A tomb is a crypt. So row becomes, no, it's OF becomes YP. Someone offering a prize for completing a task. The 60% refers to the amount of word that is still correct, which means 75 out of 8. That is exactly 1/4. So again, 2 letters wrong. So this is basically a roundabout way of giving me the enumeration, assuming that it's always 2 letters that are wrong. So a strongly held belief, that is something like a dogma or a tenet. This is a hot Finnish room. This is a sauna. Huh, okay. Oh, I see. These are alphabetical by what they would be after the modification. So I'm going to switch that around. I'm going to say that CE became NA to make sauna. Someone offering a prize for completing a task. That is a rewarder. Okay, I don't think I should have reordered this, because maybe this is not alphabetical. So I'm going to say there's a sauna, and I'm going to yeah, I don't know. I think I'm just going to use numbers now, right? These are now number 1, 2, 3, 4, 5, 6, 7, 8, and these are numbers 1 and 3, but this one here is 8. There we go. Let's make this a little bit narrower. There we go. So the source changed from CE to NA. So I believe that this one here is a rewarder. So that would be CO becoming WA in clue number 4. Something completely alone is isolated. So that's this one here, and NF became SO. Me in real life. A dried fruit. Which one of these is 2 letters away from a dried fruit? A dried fruit could be a raisin or a sultana. Strongly held belief is a the convention. This is a convention, and this is a conviction. Bingo. So number 7 is changed by changing EN to IC. Okay, so someone who's extremely hungry. It says 75%, so this is an 8-letter word. I should probably have checked the, you know what I'm going to do? I'm going to write the enumeration. So the ones that say 60% are going to be 6 letters. And then 75 is going to be 8 letters. And then that would have to be 10 letters. So it can't be sport stacking. It would have to be stacking that is 8 letters. Okay, so that would have to match with someone who's extremely hungry. Starving. Starving. CK is RV in number 2. That leaves us with number 6 here. The dried fruit, and the enumeration is 6. So it's not pride flag. Rainbow. Raisin. No. Rainbow is 6 letters. Gay flag? No, that's 7 letters. Gay pride would be 8 letters. Oh, am I dumb? Yes, oh, I am dumb. Thank you. 60% is 3 out of, well, 3 out of 5 correct. So 75% is there. Yeah, that's 2 out of 8 is 1/4, which is 75%, which is 25%, but you get the idea. So yeah, and this is 2 out of 10. So I think I got the others right. So this is actually a 5-letter word, and therefore pride would actually fit the enumeration. But what is it's a prune is what it is. There you go. ID becomes UN. Okay, and since this is not reading, this is not spelling out anything, I'm going to sort this by column C. And now we get lack of confidence. Okay, lack of confidence. I'm going to assume that that is the answer. Lack of confidence. Bang! We got lack of confidence. Yes, I got lack of confidence. No, I don't have lack of confidence. I think I'm doing fairly well here. Image recognition. Okay, that was that. That was a very cool puzzle. Nice and short and simple, and you know, makes you feel like it's rewarding. It makes you feel smart. Okay, what do we have? Pog. Okay, that takes us to the pointless task. Now hang on, I just vaguely remembered that Penzo said that one of these puzzles requires special knowledge, and I don't want to get stuck because of it, so I need to remind myself which puzzle it was. It was Scrolling up the chat here on my phone, it's the pointless task. Indeed, it is. Oh wait, no, he said that one is neat. So I guess we're looking forward to that, but which one? Where did he say that? I cannot find it anymore. Let's scroll up a bit further. There we go. The solitary task is the one that I need to worry about. So, the pointless task is still fine. Interpret these useless statements. The first letter of the answer is the first letter of the answer. That is extremely useless. Unless, of course, it's the first letter of, quote, the answer, unquote, in which case it's a T. Alright, let's see. Let's do this. Pointless. Bang. Put that here. Make everything bitter 12 and make this zip. Whoops. Okay, so the first letter of the answer could be either T or maybe it's the first letter of the word answer. The second letter of the answer appears in ASCII. Okay, so this is an A or a T, this is ASCII. The third letter of the answer is part of Unicode, okay. The fourth letter of the answer is a Latin character. Okay, let's just do that. Fifth letter of the answer is the fifth letter of the solution would be O, or solution would be T. The sixth letter of the answer features in English. Well, English already contains in, so the seventh letter of the answer is used in typography. The eighth letter of the answer is found in writing. The ninth letter of the answer is used for study. The length of the answer is the length of the answer, which is 9. So the word the is included. So I'm going to be careful here. In. There you go. Okay, so let's concatenate all of these. Put that in, nope, put that in Nutromatic. Like this, and let's close that. And we get total. That is very, very appropriate. Tautology, very cool. Okay, tautology. Bang. Okay, that was a bit quick. Okay, let's uppercase that. And this is pointless. The prize task. What will the contestants bring in and how many points will they get? Bring me the thing that can hold the most people. 1 through 5 points. Bring me the thing that is most like Li Shang's coursing river. This is referencing the first Mulan movie, the one from 1994. You must be swift as the coursing river. So we're going to be looking for a Pokemon. Maybe it has swift in the name. Swift, nope. Maybe Swift is it's not a type, is it a move? It said most like, so maybe it's just something like Swirlix, you know, just because it starts SWI, it's the most similar to the word Swift. Bring me the thing that is most valuable to Nigel Richards. Nigel Richards is the world Scrabble champion. Why would valuable. Okay, this is talking about Scrabble scores. Base speed stat. I see. Do they have speed stats? Okay. Right, I'm going to do these one at a time. So let's start with this. This is Croatia, so population of Croatia. And let's do this here. I wonder why it is so unable to just drag this to the far right. This is the prize task. So we have, let's see, let's make sure that, yeah, it is Croatia. So we have Croatia. And I'm going to put a population heading on top. Let's make everything bigger. Make it bitter. Bigger, bitter, haha. So the population of Croatia, I'm going to use Google for this because it just gives me the answer straight here. So that would be 3.899 million. Million is e to the 6. So I'm going to write it like this. No, can you please turn that into a number? Just number. Thank you. Okay, and then let's do this. Okay, can I format this as literally just a number? Right, there we go. Okay, this is what I want. So that's the population of Croatia. The next one is, I think that's Greece. Let's see if, no, not news. I want images. There we go. That is a map of Greece, and that does look very much like Greece. So what is the population of Greece? Go back to all, and we have 10.64. Okay, so that's 10.64 million. And then we do that. There you go. And that is Greece. And then we have this one here is China. So the population of China. Is it China? Yep, that is most definitely China. Okay, so it's this E9. So let's do this and then click that. China. And then this one here I don't recognize immediately. So we're going to use that. See if I can recognize Nigeria. Okay, that looks plausible. Yeah, let's just see Nigeria images. Does that fit? Yes, that does fit the shape of Nigeria. So what is the population of Nigeria? All in Google, please. Give me that E6. That E6, and we do this. Nigeria. So I think I messed up the order here. We have Croatia, Greece, something, then China, and then Nigeria. And no, Nigeria. Sorry. Nigeria is the something, and then the last one. Let's go here to find this one. That is here. It's not finding it quite as easily, is it? Okay, I do not recognize this country. So let's think. It's a country with a small island of here. Let's see if ooh, there is some imperfection here. I wonder if that can reveal something, but no, let's not use that information just yet. No, but I don't recognize this country, so it could be anything. Let's look at a map of Africa. Maybe I can find a country that looks like this. Let's see, that would be... Okay, I'm not seeing it. It's not Burkina Faso. It's not Gabon. It's definitely not Zambia. It doesn't seem to be any of these, so let's look somewhere else. Maybe it's in South America. Pick this one here, perhaps. Yeah, I can already tell it's none of these. So what about there's too many countries in Asia. Ooh, could it be this one here? Jordan. Let me just look at other countries. Okay, so I suppose it could be Jordan. No, that is not the shape of Jordan at all. Map of Middle East. Let's just zoom into this a little. This looks promising. It could be Yemen, bingo. It is in fact Yemen, and it has this little bingo. Okay, so population of Yemen. Oof. That is this E6. Let's do this, and that is Yemen. Okay, so the one with the highest population is obviously China. I could have told you that without looking up the numbers, but I'm just going to assume that the puzzle probably requires me to what will the contestants bring in, and how many points will they get? I don't know. Okay, so let's find out what these all are. This is Croagunk. Is that the, I need to make sure that it finds me the English name and not the German name, because some Pokemons have actually been renamed for the German translation. So Croagunk. Let me go here, find the Pokédex, and then just for convenience, let's put it in here, and then let's see if Croagunk actually looks like this. Okay, that is Croagunk, 100%. So since that image is here, you know what? I'm just going to put that in my clipboard. Okay, Croagunk. Croagunk. Okay, Pokemon. What was its speeds, right? And this is, of course, country populations. So I'm going to write down the names of these first. This appears to be Ferroseed. Go back. Ferroseed. Click. Yep, that is Ferroseed. Again, they are alphabetical. That is a nice form of confirmation. Scyther. Okay, let's go here. Scyther. Yep, that is. It's not entirely identical, but there you go. Now it is. Okay, Scyther. Go back here, and then let's search for this. That seems to be Shroomish. Looks like this. Yep, that is Shroomish. And then we have this one. Zippity Zappity Jolteon. Jolteon. Click that. Yep, that is Jolteon. Okay. Wait, Jolteon is not alphabetical from the others. So these are not in alphabetical order. I wonder if that's a bug or if I made a mistake. If any of you know what's going on, go ahead and tell me. But in the meantime, I'm going to ignore that, and I'm just going to look for speed. EV yield, is that what it's talking about? Oh, there we go, speed. 130. Okay. I don't know what's up with the min and max, but I'm just going to use this. That is a 35. That is a 105. Ferroseed is 10. And finally, Croagunk is a 50. It could be a coincidence the countries aren't... Oh, are they not? Oh, indeed, China is out of place. Because I marked it green, it didn't jump out at me. Thank you for pointing it out. Okay, so the highest speed, according to this, is Jolteon. Let's remove this column. And let's actually do this, because I like doing things. Alright, I like doing visual things. Let's also do this. There you go. Let's do that, and then that. There you go. So the third and last thing here is, okay, so for this I need a Scrabble point calculator, which I know I've used before while test solving an MITMH puzzle. I can talk about these now that MITMH is over. We're looking for broccoli. That is not how you spell broccoli. This is how you spell broccoli, and it turns out the score is 14. Broccoli is 14. The next one is raisins. I'm gonna assume that it's the plural. Then we have potato. Again, not alphabetical, so yeah, I guess it's not supposed to be alphabetical. And then finally we have, I don't know what that is. Is that leek? Is that asparagus? It is asparagus. Asparagus. Thank you for your help. That is a 12. Okay, so it turns out that broccoli is, broccoli, I didn't actually Google for this. Let's just make sure that it is in fact broccoli, and that this is in fact raisins, not sultanas. Looks like raisins. Okay, perfect. That is Scrabble scores. I wonder if any of you are impressed that I didn't need to Google for Nigel Richards. I want to point out that lately I have been watching a lot of Scrabble related videos, especially by a certain what was it? Will Anderson, I think is the name. Scrabble YouTube. Will Anderson, bingo. I highly recommend this channel. It is extremely informative and also very, very entertaining how he runs you through Scrabble games with amazing things going on. Amazing things that you wouldn't see if you just watched the game itself, because it goes on in the players' minds, right? He analyzes the game and the games and tells you like what they were thinking. And by the way, this is Nigel Richards. This is Nigel Richards. And Nigel plays in The Crowd Goes Wild. This is one of those videos where Nigel Richards made a seemingly trivial move, but it, you know, the consequences of that move, like he was like thinking ahead so far. It's okay, so now I need to figure out what to do with all of this. What was the flavor text? What will the contestants bring in, and how many points will they get? Well, if these were letters, that would be NGHL, so it's probably not that. What will the contestants bring in, and how many points will they get? Bring in and points. I'm a bit stumped here. What if I divide all of these by 5? They seem to be divisible by 5, all of them. So that gives me, yeah, it gives me J, B, U, G, and Z. J-bugs. J-bugs. J-bugs? Is that a thing? I'm gonna go no. I hope that this is a coincidence. What will the contestants bring in? I think I am stuck on this. I am not quite sure what to do here. Well, China, the number starts with 14. Jolteon starts with 13. This is 14. There's also a 12 here, right? So if I take those as A1Z, I get November, Lima, Mike, November. So N, L, M, N. But of course, any one of these, like for example, 14 could instead be AD, or or the 12 could be AB. Or this could be AC, or this could be AD, or any combinations of those, you know. So if I do this, we get nabmad, which is not a word, but at least it's pronounceable. If I read that backwards, I get damban. That's what happens if you if you deny access to the forest to the beavers. Yeah, then the beavers won't be able to build dams, so it's a dam ban. Okay, sorry, I'm getting sidetracked. What is going on here? Why does it say 1 through 5 points? Oh, 1 through 5 points. Okay, so I should actually sort these. Wait, hang on. If I'm supposed to reorder these, then they should be in alphabetical order to begin with. Why are they not? That is weird. Okay, let's put something here. Let's merge that, and let's say that this is in first place. Let me make this it's easier to see which one's the larger number. 1, 2, 3, 4, 5. Right? And then we do this. So here we have so in first place, and then 2, 3, 4, 5. And then we have these. First, second, third, fourth. I'm still not sure what's going on here. If I take the first letter here, the second letter here, the third letter here, the fourth letter here, and the fifth letter here, I get this. Is that a word? Yeah, if you replace the M with a V, then it's an animal. And yeah, I'm familiar with that, but not with an M. Okay, let's try this one here. That would be J, C. Okay, so it's not that. So it says 1 through 5 points, so maybe 5 points is for the one with the most. So it would be 5, 4, 3, 2, 1. In which case we get Croatia and then Greece and then Yemen. We get CRM and then E and then A. Okay, that's Crimea with an I missing. Let's continue. So the smallest to largest gives me this ordering, and I end up with F, H, O, and then the fourth one here is a T, and then 2, 4, 5. Is there a Pokemon that is F and then a vowel and then H-O-T-E? No. O-T-E? Also no. No, I don't know about this. So 1, 2, 3, 4. So again, we're gonna reverse that. 1, 2, 3, 4. We get raisins, and then the second letter of potato, third letter of asparagus, and the fourth letter of broccoli. That could form the word crop, but only if you shuffle it. This could form the word America if you insert 2 letters and reshuffle it. Yeah, I think I need a hint here. I'm not quite sure what to do. Bring me the thing that can hold the most people. Bring me the thing that is most swift. Bring me the thing that has the highest Scrabble score. Well, it is 7 o'clock. I believe that Penzo said he would be here at 7:30. Yeah, he did. I'm going to send him a message and say, when you're back, I may need a hint on the prize task. I want to say something like, send me a message on Discord so that I can show on the stream what I have. Penzo is in the chat. Okay, well, that doesn't mean he's actively watching, though. Penzo, if you're actively watching and you can hear me, then let us know. But, okay. Let me know when you're back so I can show you what I've got. Click. Okay. Let's move on to the next puzzle after that. The next puzzle is the reconciliation task. That is reconcile the opposite but interconnected forces. The opposite but interconnected, these seem like logic puzzles, but they're not mass use. And apparently this is a single Penpa puzzle. I don't know the rules of this. Does anyone know what logic puzzle this is? I can't tell. Opposite but interconnected forces. Yeah, this is probably supposed to hint at a logic genre, but I just don't know what it is, which one it is. Is it yin-yang? Could it be yin-yang? Opposite by interconnected forces. That is what yin-yang is in Chinese philosophy. I'm going to assume that it's a yin-yang puzzle. Yes, it can be yin-yang. Okay, thank you. So let's actually try to solve these as yin-yangs. So I believe that if you have like a black and a white next to one another at the edge, then the entire... No. Right, yeah, but I think that these are all... Oh, can I not draw circles? Apparently not. Okay, but these must all be black. And this must be black. And these must be black. these must be black. And these must be white. Yeah, it's a little annoying. I think I'm going to mark all of the white pearls green and all of the black pearls black. It would have been nicer if I could draw actual pearls, but you know, if I have to jump through hoops for that, then maybe not. This would form a 2x2, and so would this, and it has to come out. These are all black things, and I will mark all of them with my mouse. There you go. This has to come out. And then these, obviously. Click, 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 click. Oh, this was my favorite one of the set. Penzo, you are actually here. Can you give us a hint on price task? So, just to show you what I have found the country population, Pokemon speeds, and Scrabble scores. I have ranked them from 1 through 5, and 1 through 4. And I tried to index that number into each of these, and that gave me this. And I thought, okay, that's 1 letter away from Crimea, but then I'm not getting anything readable from the other. So if you could give me a hint on what I need to do next in this puzzle, I would be very obliged. But for now, I'm going to try this. Click, click, click. That is a 2x2. Click, 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 click. Now, come on, click, click, click. Ooh, and if that is white, then the rest of this all has to be white. There you go. That would be a 2x2, has to come out. 2x2, 2x2, 2x2. That has to come out. Okay, this would be a 2x2. Can you go back to the spreadsheet? I didn't catch what you had. So please take a screenshot of it now so that you can look at it at your own leisure. And then once you've taken a screenshot, I will switch back to the pen pal. Okay, thank you. That is a 2x2, 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 2x2. That is a white. That is a 2x2. This one, I don't know. 2x2, 2x2. Let's see, there is a white here. So all of this, whoops, has to be white. And these have to be black, which makes that a 2x2. That a 2x2, that a 2x2. And we can't have a checkerboard, so that is also forced. The white has to come out. That has to come out. Okay. This one here is quite... oh, there is a lot of white on the edge. There you go. I was about to say this is quite bare. There's very little givens, but there you go. We have got quite a fair bit to start off from now. That is a 2x2. That is a 2x2. Okay. What other obvious? This is a checkerboard, so that's a 2x2. Does that have to come out? Yeah, one of those two has to come out. Don't know which one yet. That is a 2x2. Here is a 2x2. In fact, that has to come out as well. And that is a checkerboard, which means that now this has to come out. Whoa, we actually have a checkerboard here, so I made a mistake. Whoops. My hint for price would be, is the ordering relevant? Well, okay, so I did notice that these are... oh, I'm stupid. I can just CR, and then the fourth letter here is an E, and then the fifth, it's just cream. Yeah, okay, Jesus Christ. That was actually embarrassing. 2, 4, 5. Cream of the crop. Okay. Thank you very much for that hint, Penzo. Cream of the crop. Yay, that is correct. Let's go back here and put that down for prize. And the next one is reconciliation. Okay, let's remove those and continue with this. So I think I made a mistake here. So this has to come out, this has to come out, and then we have the checkerboard rule. That has to come out further. That is a checkerboard thing. That is a 2x2. And then this is a checkerboard thing. And then that is a 2 by 2. So, and that is also 2 by 2. So again, we're left with a checkerboard. So I think I messed up somewhere. So I'm going to start over from the beginning just to make sure I do everything right. I need to pay more attention to it now. So again, let's mark all of the blacks and all of the whites. Click, 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 click. Not that. This black has to come out, definitely. Black, 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 black. Whoops. Black, black. This has to go all the way around. Oh my gosh, that was terrible aim. That is that. Okay, nothing else on the edge here. Click, 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 click. There's literally nothing on the edge here. This is here. This is a checkerboard thing. This is a checkerboard thing. And this is a 2 by 2. This is a 2 by 2. Penzo, could you just, for the avoidance of time wasting, can you just confirm that I have the rules for yin-yang correct, which is that the blacks and the whites each have to be a contiguous area, and you're not allowed to have any 2 by 2s. If either of those conditions is wrong, then please tell me. This is a 2 by 2, sorry, a checkerboard rather is what I meant. And then let's do this one here. That has to be connected. You've got the rules for yin-yang correct. Thank you. Okay. So that would make a 2 by 2. That would make a 2 by 2. That is a checkerboard thing. That would make a 2 by 2. That's a checkerboard thing. That has to come out. That has to come out. This black has to, yeah, this is a checkerboard, and this has to come out. Maybe I went wrong here. No, it was this one where I went wrong. Whatever. I'll just do it again. So I might have said that this has to come out, but of course it doesn't because it can continue here. So let's, so this is white. This is black. Okay, don't see anything else here. There is lots of potential 2 by 2s here. This is a checkerboard. This is a 2 by 2. This black has to come out, so that is black. This also has to come out. But these can absolutely connect, or it can be more white. We can't tell at this point. Here, the white has to come out. But besides that, there's very little here. Also here. So, I suspect that the same colored rectangles are probably clone areas, which is why the whole thing is implemented as one pen per puzzle instead of 9 separate puzzles. Excuse me, 7 separate. So I'm going to assume that these are white because those two are white, and that this is black because this one is black. So that would make this a checkerboard and this a 2 by 2. And then here the black has to come out and come out further, like this. And that's basically that. Let's see what else we can deduce anywhere. It's kind of hard to believe that this is going to be unique, even with the green and the cyan filled in, right? But I have to trust that it is unique, or that there is some other rule. No, there's no other flavor text, no other hint, so I don't think there is another rule. So, maybe there is something, like, you know, maybe if I put something in one of these clone squares, it will create a contradiction by virtue of them having to be equal. Not quite sure about that. Oh, there is a 2 by 2 here that I missed. But that doesn't tell me anything. I mean, this black stuff has to come out, so either one of those two is black. And if it's this one, then that would clone over to this here. But that is obviously not a contradiction. Like, this one here is very, very low on information, it seems. What else can we deduce? I completely neglected to mark all of these, and none of you shouted at me. But then again, oh, there we go, there is a lot of white on the outside. Oh, there we go, so that is a 2 by 2, that is a 2 by 2, and that is a 2 by 2. That seems to be it, though. Aha, if I put a black here, then the checkerboard rule would force this, but the 2 by 2 rule would force this. Therefore, this has to be white. Does the same apply here? If I put a white here, it does that. And if I put a black here, then it does that. So no, both of those work. That is a 2 by 2. I wonder if that kind of contradiction occurs somewhere else, like in a different grid. Okay, so here is a kind of deduction that I could imagine. Right, we can tell from this grid that these can't both be white, because that would make a 2 by 2. And therefore one of those must be black, and therefore one of these must be black. And I wonder if I can somehow use that kind of logic. But I don't know which one of these two. Okay, so let's just put a hypothesis. If this one is black, then... yeah, it doesn't even imply anything right now, does it? Maybe I can deduce something from this. If this is white, it would make this black. And if this is black, it will make this white. This, oh wow, before even doing that, this white has to come out. And that, okay, that doesn't really have an impact on this, but okay, so if this is black and this is white, yeah, I don't really see how that implies anything. So this could be white, it could be like this, and that would still work. Okay, so let's try to use that realization I just had elsewhere. Not in the purple, because that one doesn't have any... oh, wait a second, I have some white here. That has to connect to the other white on the outside here. Now, at this point, that is a black, and that's black because of a 2 by 2. I'm wondering if I can imply something about this here. But I don't think I can. If I make this black, it has to come out, but then that is fine. And if it's white, then any of this can still be black or white. Alright, well, let's take a look at some other clone regions. Okay, so we can see that there are two blacks here, which means that one of these has to be white, and therefore one of these has to be white. Can it be this one? Because if it's this one, then checkerboard rule here, and then this has to come out. There is no contradiction I see there. This is hard. Okay. If I make this black, it forces this white and then this. And again, no contradiction. It just stops there. Like, the deduction just stops there. It would obviously make this, no, opposite, that. But nothing I can deduce here. Whew. So, what else can we say? Am I on the right track here? Penzo, if there is some other rule that I'm overlooking, either yin-yang rule or something, am I right that these are clone regions and also that that is the only extra rule on top of yin-yang? If there is anything else, then please just tell me that there is something else and I'll see if I can figure out what it is. I see that. Okay, so here you can't have two blacks like this or two blacks like this. I think you've got the correct rules. There are some harder yin-yang deductions. I see. Okay. So, if this were my gift, I would be tempted at this point to write a solver for this. And I have not written a yin-yang solver yet, I believe. I wonder if I should do that. Would you guys actually find that interesting to watch? I don't know. But let me know if you want me to point to a particular spot. Yeah, actually I think that would be helpful because I'm not that familiar with advanced yin-yang deductions. And there is a lot to look at here. Timmy programming stream. Yeah, I mean, I do a lot of programming on my streams, and I thought that, doing puzzles would be a nice change of pace, which is why I'm resisting doing it now. So let's see. Wait a second. One possible deduction is that, like, for example, right, you can't have this white, you can't have this white connect with this white because it would isolate this block of black. Okay, here's something you can do with the 3 diagonal white cells in the bottom middle puzzle. Yeah, okay. Let's take a look at that. So if I were to make this a black, it makes that a white, and that a white, and that a white, and then black. Not seeing a contradiction there. So my hypothesis was that is a black. What if that is a white? It makes that a black, and that's it. Okay, well, but I guess what I can say is that these whites have to connect to one another, right? It has to form like a diagonal line, which means that the black part has to go around it. That's a bit vague, because obviously all the black has to go around all the white. So just making sure I didn't miss a message. There's something you can do with the 3 diagonal white cells in the bottom middle puzzle. Oops. Okay. What can I do with these? What if this is black? It forces that to be white and nothing else. I think I need something other than the spot to look at. I need like the direction to think in, because that's always my issue, right? All I can do right now is just place hypotheses and hope that I get a contradiction pretty soon. And I don't seem to get any here. If this is black, then this is white, and then checkerboard forces this. Checkerboard forces this. That is a 2x2. And I think I had that last time. Why would this be a contradiction? Because, check the cases for row 4, column 2. This one here. Okay. Right, so we start with this. So if this is white, Now, if this is black, right, then we need this and this, and then we have that. And then something about this. This could be white if it connects like this, but it could also be black if the white comes out. So that is not clear. So this left column is a black thing, right? It has to come out either here and then through the yellow box, or through here. But both of those are totally possible. Sorry, my bad, it doesn't do the thing I thought it did. Ah, okay. And that is unfortunate. Okay, well, can you point at another spot, perhaps? What about this? It does that, and it does that, and that, and that. A different spot you could maybe look at is the borders on the top right puzzle. Which parts can't be all black or all white? Oh, you know, that is very clever. I hadn't considered that. Okay, yeah, so, yeah, that's clear, right? So these can't both be black, and these can't both be white. Okay, so we have to have either black going all the way around here, but then this corner would be violated. Therefore, this all has to be white, like this, and this all has to be black. Bingo. Oh, that is very cool. If I make a wrong deduction, please stop me for the, in the interest of not wasting time. Okay, so for the avoidance of time wasting, right? So these all have to have 2x2. This is a checkerboard. This is a 2x2. This has to come out. Whoops, this has to come out, which places a black here. Yeah, that doesn't do anything yet, but maybe the next one does. Let's see. Okay. I'm not sure it goes that far, but that's the correct idea. But it... Oh. You're not sure it goes that far. Okay, maybe I should pay more attention to the logic. So my idea was the following, right? This has to contain a black. Ah, but this one doesn't have to contain a black. This could just be all white. What was that last message? It's been a while since I did. Okay, that's fine. So I'm thinking... Ah, wait a second. One of these has to be white. They can't both be black. Whoa. How did that happen? Oh, how do I turn that off? Oh no. Ah, I pressed tab. That's what happened. Okay. So these can't both be black. They have to contain a white. So either this one's a white, in which case they're both white, or this one's a white. So this one is definitely a white. And then that gives me an entire border around here. And then that is a 2x2, 2x2, 2x2 checkerboard, 2x2. Come out. Whoop. Whoa, that was my mouse just slipping. That comes out. That is a 2x2. Nice. Yes, thank you. That is black. That has to come out. That makes that a 2x2. Okay, that's it. But that white goes here. Okay. There's still very little activity in the clone regions. I think they're very cleverly placed to be like the last part that you do. For the right puzzle, it's just row 1, column 3 to row 1, column 3, so this one, to row 9, column 1. Okay, I see, because one of these has to be white, and one of these 3 has to be white. So you have to have at least this. And that places black here and here. And then you get a black here because of a 2x2. You cannot, right, okay, so this can actually not be black, because if it were black, the next one would have to be white, right? But one of these has to be black. So if this is black, then, you know, whatever is black here would have to connect with that black. So I just, yeah, no, I think that's right. Wait, hang on. Okay, there's one logic step that I didn't say explicitly, but I should say, which is that one of these has to be white and one of these has to be white. So I said, okay, therefore these have to be white, but actually it could go the other way around. But now I can add to that the logic that it can't go the other way around because it would make a 2 by 2 here. So I can restore this. Okay, now I'm going to argue that this can't be black, because it would force there to be all this black, and then you would have 2 by 2s here. Therefore, this is white, and then by the same argument, this is also white. Now, if this is black, it would connect to at least here, and then the rest would be white. There has to be a black here. So if you were to put black here, it would make all of this black. Bang, there's a 2 by 2. So you can't have that. Okay, but now all of this could be either, right? The entire rest of the border could be entirely black, or it could even be entirely white except for one, well, except for a few blacks here, right? It would have to be a black and it would have to come out. So I don't think I can deduce the rest of this edge. And all the other edges I've already looked at. Yeah, the rest of the border is still ambiguous. Okay. So I need another advanced deduction, I guess. Let's see if I can... So is there actually something I can do with these 3 diagonal whites, or is that now dead? If I were to put a white here, let's see what happens. Curiously, nothing at all happens. Right, this would form that, and then that would just work. That has to come out. That looks fine to me. Okay, and then this would force that, and then that, and then that, and that. And now, interestingly, it forces this. Because without this, if this were white, then we would have an entire path of white going from the top to the bottom, and that is not allowed. That would separate the blacks. So maybe that is the kind of deduction I need. I need to check for, you know, whenever... Like, there is very little black on the edge of this one here, which means that none of the whites... Like, for example, you can't have this piece of white connect to this bit of white, right? I need to pay attention to that. But unfortunately, you know, the interface here is 3 spaces, so it's not like here where there is a single... So, why don't we? Because we now know that the black part on the left here has to come through either this little hole or this little hole. Sorry, the 3 white thing was a wrong thing from my end. You made a good deduction in the green-blue grid. You can continue there. Green-blue, right? You probably mean green-cyan. So you're saying I can continue here. You're saying there is more to be deduced here. What could you be referring to? Okay, the same happens here, right? You have only very little black on the edge, at most 4 squares, and so all of the other black has to... Yeah, but it doesn't have to go through here, because this can already connect, and then you can connect all this black up here, and you can connect all this black down here, so it doesn't have to go through here. But what if it does actually go through here, and we get this? Does that contradict the white somehow? No, because we can just connect the white like this, and then the black can do something like that. I don't think that is a contradiction. There is a black there is a 2 by 2 here that I missed, but I don't think that does anything. If this is black, it forces this to be white, but now this block of black has to come out, and you get this sort of horseshoe shape. But that is not a contradiction, is it? Conversely, if this is white, then obviously this black stuff has to come out, and that is also totally possible. It would transfer two blacks to here. Bingo! And there is a contradiction right there. Okay, so alright, so the logic here is if this were white, it forces this black to come out, and that creates a contradiction down here. Bingo. Therefore, this is black, which makes this white and that white. And then this L shape has to come out, so it makes this black. Very cool. This is also a 2 by 2, which I haven't noticed, which I failed to notice. What else? Can we do something similar here? Because I noticed that there are two blacks here, which means that this cannot be both blacks. Let's see if we can somehow force them to be both blacks. No, I don't think we can force that, not with this. Because if I put blacks like this, you know, they're not both blacks. You end up with this, and that is fine. And that just works. Okay, we need to make sure that all of the blacks are connected though. Right? I can't have this, because that isolates this bit of black here. How can I leverage that idea? Don't really see how. Okay. I just noticed something. No, I did not notice something. So what I was about to say is that because these can't both be white, it must contain a black, and therefore one of these is black, which makes this a connected piece, right? And then I was going to argue that it cannot connect to this piece, but of course it does connect to that piece. Nothing here is threatening to be isolated. Okay. So here's another case where we can't have two blacks next to one another. So one of these is white, but that doesn't really help here. Should I continue here? Is this the correct place to look at? Let's see. Hypothetical. If I place a white here, then the black has to come out. But the white doesn't necessarily have to come out. So that doesn't actually force anything. And nor does it force anything down here. So alternatively, if that is a black, it forces this to also be black because of the checkerboard. And then of course we have the 2 by 2 here. But that also works just fine. I don't see a problem with that. Nope, that is not. Wait. Okay, this is what the hypothesis was. Yeah, give me another pointer there, Penzo, if you could. Is there some logic about the fact that this little piece of black here needs to... Oh, yes, no. I was about to say, yeah, it needs to go through here in order to connect to this, but it doesn't have to. It could connect to the bottom part here, and then connect here, and then through here. It could absolutely do this. Another point now that you see how the connected region deductions work is the indigo one. So you mean purple, right? Dark blue. Okay, you mean the dark blue. Well, I looked at this, right? I know that these can't all be black. In fact, you can't even have two blacks next to one another. Ah. So if this were... No. Yes, if this were black, then the checkerboard would force 3 blacks here, and that is a massive contradiction. Therefore, this is white. Therefore, this is white. Okay, cool. That's it. What else? What? How was that supposed to... how was that supposed to be groundbreaking? Let's see. If I... if I put a black here, it does this and this. Again, not a contradiction. And if I put a white there instead, if I put a white here and here, there's also nothing going on. Nope, that does not help. So is there more than just this one cell that I just discovered? This is both interesting but also difficult. It's a lot of small steps. I'm trying to remember to. Thank you, I appreciate it. Let's see. Let's try this. I meant this. If that is the case, then this is black. That doesn't get me anywhere at all. I don't really know how to do, you know, sort of big deduction, like you know, big picture kind of deduction. I just noticed there is a black 2x2 here. Doesn't really do anything, but it's good to know that there is one more. Can this be black? If this is black, right, and we know from up here that one of these has to be black, and we cannot form a loop, so it would have to be this one. But then anything goes. Not getting anywhere. If this is black, if this is white, then obviously this is black. and then it has to come out. But if this is black, more generally, if this is white, this just has to come out. But if this is black, I need to somehow rule out this possibility. But I don't think I can do that yet. Oh yeah, sorry, I completely missed a thing. Well, if it's any consolation, I'm missing it too, apparently, but there you go, orange-yellow puzzle. Orange-yellow is this one here. What about it? Okay, one of these has to be white, which means one of these has to be white. Can it be this one? The answer is yes, it absolutely can. The border. Ah, Jesus Christ, that is embarrassingly obvious. Okay, that makes it black, 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 black. Okay, this black has to come out, so that goes here, and that makes us a checkerboard, and then a 2x2, and then that is a 2x2, and that puts a white here, which means checkerboard rule, and this black has to come out now. Okay, very cool. So the only things left on the border besides these little individual ones is this big one here. Right, so I know that one of these has to be white. But yeah, the only place that needs to have another black is here. So I don't think this can be deduced yet. Okay, so where were we? We were here. Let's see if I can deduce some more from what we just got. The yellow, perhaps. Yeah, not sure. Okay, so this black. Okay, so this black thing is already forming a bit of a frame, right? So we can have one more connection like this, but if we do, then this cannot connect, because otherwise it would form a loop. It's not allowed to like fence in any of the white, and that's why it's not allowed to form a loop. Which means that if this is black, we get a contradiction. Because if this is black, then because of this checkerboard thing, that and that would have to happen. And then you have that being white, and then the checkerboard is violated. Right? I mean, the reason I saw this is because this and this sort of already connects the black, right? I mean, you can include diagonal connections in this logic. Right? So this has to be white, which means that has to be white. Now, these cannot both be black, because if they are, then these two whites are isolated. So let's see if this can be black. Well, if that can be black, then the checkerboard would already do that. So no. So this is white, and then this is a 2x2. This is a checkerboard. This has to come out. So that's a 2x2. That's a 2x2. This has to connect the black. This is a 2x2. This is a 2x2. This is a checkerboard. Boink. This is a 2x2. And now, and now we have this situation that I described. You see, if this were black, it would form a line through, or differently put, it would form a fence. So this is white, and then by the checkerboard rule, that is also white. And this one is also a checkerboard thing. And now these two blacks here have to come out. Okay, bingo. We can now fill in this. This piece of black has to come out. This cannot form a 2x2. This is a 2x2. This is a checkerboard. This is a 2x2. This is a checkerboard. This is a 2x2. This piece of black has to connect to other black. And now we have this extra. And this horseshoe black has to come out like this. All right. Now I'm making good progress. Thank you for your help. Ooh, this entire shape here. Look at this. This is entirely fenced in except for that square. So it has to come out here. But now it could either do this or this. So it's probably... this one can also do either. It could do this or it could do this. Okay, we'll come back to that later. There we go. If this were white, we have another connection here from one edge to another and along this edge. So that would fence in the black. So that is definitely black. Right. I wonder if I can do that same logic elsewhere. I'm looking at all of the grids here. I hope I'm not missing something obvious. Because the thing is, if you are currently seeing something and you're staring at it and screaming at the screen, it's entirely possible that I'm looking somewhere else entirely, you know? Okay, so this black F thing has to connect to the rest of the black, and this is the only place where it can do so. It has to go all the way there, and then this, and then this, and then this. We have our first completed grid! How amazing is that? Okay, we have a checkerboard. That is also a checkerboard. That's a 2x2, 2x2, and that has to come out. Okay, that white has to come out. This entire black thing has to connect, like, okay, so this piece of black has to connect with all the other blacks. Yeah, I'm not sure if that's helpful. Nice, first grid solved. Yes, thank you. Okay. Did I transfer both of the clones? Yes, I did. Okay. Something tells me that this is white and I don't know why. I think that's just an intuition, it's not real logic. Okay, well, the remaining grids are all still, like, open and ambiguous. Aha, look at this. We know that these can't both be blacks, therefore these can't both be blacks. Can I use that to my advantage? If this is white, no, I have to approach this differently. If this is black, right? Yeah, unfortunately these blacks can connect in all sorts of ways, right? You could either have that or you could have that, and both of those just work. Ah, but this doesn't. This doesn't work because you can't have two blacks here and you can't connect down here either. Okay, so if this is black, then this one can't also be black. So then we get this. This has to come out, this has to do that, this has to be that. 2x2. This has to come out, which makes that makes a 2x2, that makes a 2x2. That makes a checkerboard, and then this is white. And then these blacks would have to connect. Okay, so this is a possibility. I want to make sure that that is not the only possibility. So we've determined that if this is black, then this has to be white, and then everything else follows. Right? So what if this is white? If this is white, then these blacks have to connect somewhere, either here or here. But they could still have that. But they could also just not have that, because they can just bend around like this. Oh, this is annoying. Is there another contradiction waiting on the other side of that deduction I just made? Like if I hypothesize this again, right? So we said that this is not possible because it does this. So that is that, and that. And then we have this, that. Yeah, this part is resolved by the other grid. You can ignore it for now. I see. Okay then. So, what about the other grid? Let's see. If I were to put a black here, that white has to come out. That has to connect. That is a 3x3. That is a 3x3, which forces this, which forces this, and this, and this, and this. And yeah, multiple possibilities here, but it forces this and this, and this. Bingo. And now this is what, there you go. So it would force these to connect. And then this has to be, it can't be a 2x2. Then this is a checkerboard thing. So this is all under the hypothesis that this square here is black, right? That was my hypothesis, making this black. If I make it white, then there is nowhere near as much deduction, and I don't think it would give me a contradiction. So I'm kind of hopeful that this will still somehow create a contradiction, but it's not looking like it will. Yeah, no. If that is white, nothing happens. And this is white, nothing happens. So, not sure what to do there. Can this be white? If this is white, it forces quite a lot of white here, and this black has to come out. But that's it. That is all of the white that it forces. Somewhere else. If you have any more tips for where to look, I'd be happy to hear them. Can this be white? If this is white, look, if this is white, then it can't connect to this white, so that is black, and this piece of black has to come through. So that is a lot of deduction right there. But is it a contradiction? That is the big question. Doesn't look like it. No. Let's see. By the way, you should delete the unshaded cell in the purple row on the right. Ooh. Oh, I'm not quite sure how that got in there. Thank you. I probably had a hypothesis there. Would it help if I place a hypothesis on the lines of what if this is black? Because then it causes all of this to be black. And also this. And then we have this and this. And that's about it. Alternatively, what if we hypothesize that this is black? Because then that requires all of this to be black. Then this is white. And that doesn't seem to go anywhere either. I need a hint. Just tell me where to look. Here's another hypothesis I could do. If this is white, not only does it force this to be white, but it also forces this entire black region to come out like this. And this is a 2 by 2. And then this piece of white has to come out. And I'm still not seeing a contradiction. Can this be black? Yes, it can if this is all white like this. Okay, so what was my hypothesis here? It was this one. So alternatively, what if this is white? Not only is this a 2 by 2 now, but also this has to come out now. And this has to come out. And then that's where we get stuck. Let's see what Penzo says. I forgore, sorry. I'll try to find the next step. Yeah. Well, I'm trying to find one as well. So let's try this again, right? If this is white, it forces this to come out and this to be a 2 by 2. This comes out. This is so ambiguous here. I don't think this is the one. Maybe we need to look here. There's like nothing here. Like there's literally 0 givens or clones. Like this is predicated entirely on the orange and the red, I think. What about the purple again? We know that these can't both be white, so these can't both be white. That doesn't help. And by the way, if you guys want me to like put a break, take a break from this puzzle and move on to one of the other puzzles, I'm happy to do that. But I'm enjoying this right now, and it would be really cool if I could finish this. Okay, hypothesis. What about this? That causes that, that causes that, and that causes that, which means that has to come out. And this one also has to come out. That is a black. But now these can join up anywhere, wherever they want. Yeah. Yeah, you can actually have this go all the way to here, right? And then these could join up. But you could also have it go like here, right? And then do this. And then they're still all joined up just fine. So which one of these it is depends entirely on what happens here. Ah, wait a second, we can't have this if that causes these two. Oops. No, sorry, they can absolutely be both white. I just, they just can't both be black, that's it. What was my hypothesis here? My hypothesis was this white. So if that's white, it causes this, it causes this, it causes this, causes this. That comes out. And yes, that comes out. Or does it? Yes, it does. Okay, so after that, what else is absolutely required? What's absolutely required is that one of these two cells has to be white because of this. And that means it doesn't say anything about this. No, it doesn't. you know, it could be like this, it could be like this, it could be like this, or it could even be like this, and then this would force that, right? And then we get this, and that's also fine. Yeah, I'm really not sure here. Okay, if anyone sees any more deductions or has any suggestions on what hypotheses to try, please speak up. I think the fact that this entire black area has only these two places to come out, I think that is relevant, right? You have to have either this or both, which means that if we can deduce that one of those is white, then the other one has to come out. So if this is white, then this comes out. But I've looked at that earlier. So I gotta go away for a bit to help my dad with some stuff. Don't worry if you get stuck. I couldn't do this puzzle in one sitting, but it's great. I think you're well on your way there. Okay, thank you. I think in that case, I'm going to take a break from this puzzle and I'm going to move on to the remaining puzzles. And I'm going to just, you know, for the avoidance of losing this, I'm just going to save this as, I don't know, temp.png. There you go. But of course I'm also going to leave it open. Okay, so do we still need the Pokédex? Probably not. Let's go back to the main page here, so the solitary task. This is the one that I was warned about, that it requires some kind of physics knowledge or science. No, he said science, not physics. Contemplate unity. Your time starts now. This looks a bit more like chemistry, but actually no, these are not chemical elements. Topics. Ah, I see. Okay, I see. H3 is ozone. Yeah, I think these are, you know, phrases where, you know, one... so for example, you have like, for example, you know, if it said like, for example, what's a good example? Like, 21 P on a D, right? It would be 21 pips on a die, right? Because the total number of pips on a die add up to 21. And I think it's kind of like this, but they're all ones. So there is one W on a U7. I'm not quite sure if the 7 is an enumeration, so maybe we're looking for a 7-letter word with a U, but then, you know, why would this not have an enumeration? And also 2 seems a bit unlikely. One. Yeah, maybe I should have moved on to this puzzle while Penzo was still here and get a hint. So I'm going to move on to that later, but you know, it seems interesting. The team task: go for food with your team. Your time starts now. Go for food with your team. Menu: starters, blah blah blah. Bill: seats 1 to 5. Petra, Esther, Nadia, Zach, Oscar. There's a space missing here between the 9 and the plus. Oh my god, it's an Einstein. Oof. I don't normally like Einsteins, but I will give this a genuine go. So let's put that here. Let's also do this so I can see where they all start. Okay, so what are we actually looking for? Like, we have 5 people. They are sitting in 5 seats which are numbered 1 through 5. Let's see, this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So probably each person got 1 starter, 1 main, and 1 dessert. And then these are the total costs for each of them. You know, starter plus main plus dessert. By the way, these are very low prices. The last time I was in a restaurant, I could, you know, I had to pay like at least 10, maybe 20 euros for a starter or a dessert, and the mains would usually be like between 18 and 30 euros. Anyway, so let's see. So we have, I think I'm going to write down the names of the people first. Let's put this side by side like this. So we have Zach, we have Oscar, we have Nadia. Oh, I'm stupid. They're right there in the bills. Right, there you go. Esther, Nadia, Zach, Oscar. So it's interesting that the bill lists them in this order, which is not alphabetical. So I guess I'm going to replicate that same order. Right, and each of them is in a seat, which we don't know yet. So I'm just going to do that. And each of them so can have a starter. So the starters are C, P, Q, S, W. And then we have mains, or main, let's call it main course, which is C, M, N, P, S. And finally we have the dessert, which could be A, B, they all start with B. Oh, okay, I'm going to use the last letters, E, G, S, E, S. Okay, that's also not unique. Oh, that's unfortunate. Okay, I'm just going to call them A, B, C, D, E. No, I'm not going to do that either. Okay, Battenberg, 3rd letter. Brownies, W. Bundt cake, let's do the D, and then churros is a C. There you go. Okay, let's write that down. A equals, okay, A is clear. T equals Battenberg. W equals brownies. And D equals Bundt cake. Okay, Zach sat in a seat numbered 2 higher than the person who ordered canapes. So Zach cannot be in seat 1 or 2. And now that oh God, Jesus. Okay, oh Jesus. Yeah, this is a multi-dimensional thing. So the canapes thing, how do I write it down? You know, the only way to write that down is to, oh, also that means that Zach cannot have the canapes. I'm gonna try and, I'm gonna come back to this later. Oscar ordered quiche, good to know. That is, yep, that is a starter. So this one is quiche, no quiche, no quiche, no quiche, no quiche. Like that. Let's keep it like that. The Bundt cake, which is D, was ordered by the person in a seat numbered 3 higher than the person with cottage pie. We'll come back to that. Nadia sat directly next to the person who had amandine. So Nadia sat next to, yeah, it could still be anything. The person in seat 1 ordered salad. Petra ordered noodle soup. Petra ordered noodle soup, which is a main. The meatloaf eater, which is also a main, sat in a seat numbered 1 higher than the person who called. Okay, I'll come back to that. You know what? I'm actually going to do this. Zach, we already know that Zach is 3, 4, or 5. Sat in a seat numbered 3 higher. Okay, 2 higher than something, but also 3 higher than the person who had brownies. So Zach is 4 or 5 and did not have brownies. Brownies is a dessert. The salad eater sat in a seat numbered 1 lower than, okay. The person ordered spaghetti. Okay, right. So I have to worry about the other dimensions. So let's see. So for each seat, 1, 2, 3, 4, 5, we can have all of these. Okay. So we want to put the C here, and we want to put the Q back in. CPQSW, CMNPS. So these all get an N, and this gets a W. There's going to be so many of these, because then I also have to associate like starters with mains and mains with desserts and starters with desserts. This is going to be really, really... this is why I dislike Einstein puzzles. There's always so many connections to keep track of. But I'll give it a go. Oscar ordered quiche. Zach sat in on seat number 2 higher than the person who ordered canapes. So canapes, which is a starter, cannot be in 4 or 5. Yes. I think that's right. In fact, it can also not be 3, because then Zach would... Wait, hang on. Zach sat in 2 higher. Okay, so I did a boo-boo. It can't be any of these. Wait, what am I doing? Zach sat in a seat number 2 higher than the person who ordered canapes. So the person who ordered canapes must be 2 or 3. There you go. Now we have it. Whew. Okay, the bundt cake, which is D, was ordered by a person in a seat number 3 higher. 3 higher. There you go. Then the person with cottage pie. Cottage pie is a main. 3 higher, so this one is 3 lower, so it's one of these. Okay. I'm starting to think that maybe I should make these spaces. It might be a bit easier to see what's going on if I do that. And then here as well. And do I want to do this? I don't know. No, I want to keep the uncertain ones in a clump like this. So I'm gonna do this. And then I'm gonna do this. Right. Nadia sat directly next to the person who had amandine. Amandine is a dessert. Now, that could be any seat, so I don't think I can... but I know that Nadia did not have amandine, so I can actually rule that out. The person in seat 1 ordered salad. Salad is a starter, so that is now salad. And none of these are salad. The meatloaf eater, which is a main, sat in a seat 1 higher, so not seat 1, than the person with cottage pie, which is a starter. No, that's also a main. Yes. Meatloaf, seat... Meatloaf is 1 higher than cottage pie, and cottage pie is already 1 or 2. So meatloaf is 2 or 3. Zach sat in a seat number 3 higher than the person who had brownies. That means the person who had brownies, which is W, is 3 lower. So it's none of these. Yes, I think that's right. The salad eater, which is a starter. Oh, we already have the salad. The salad eater sat in a seat numbered 1 lower, so churros is in seat 2. And churros is a dessert. Right. So that goes here. And these all go away. Done. Phew. The person who ordered spaghetti, which is a main sat in seat number 3 lower, let's just delete that, then the person who ate prawn cocktail, which is a starter, prawn cocktail, that would be P. Wait, if this is supposed to be 3 lower than prawn and prawn can already not be 1, then that has to be... No. It can be 1 or 2, and then the prawn is, yeah, the prawn is just those two, isn't it? The person who ordered spaghetti sat in a seat 3 lower than a person who had prawn cocktail, right? So it's either 1 and 4 or 2 and 5. Okay. Now, Oscar has quiche, and quiche is not in seat 1, so Oscar is not seat 1. There is only one seat that can still have brownies. So that is brownies. So none of these. And that is the same as the starter S, which is salad. Right. That means that Zach cannot have W, we already knew that, and can also not have salad. Okay. Zach can also not have, we already know that. So it's a P or W. Oh, there's a starter, sorry. Aha. No, right, he can have P or W. In terms of mains, he can only have N or P. And N is already taken. Therefore, Zach has the P. So the main P is in seat 4 or 5. Right, so we know that 4 and 5 are N and P respectively, so this forms an X-wing, so these are not N's. I'm going to scrunch these together. Right, we also know that the S can only be in seat 1 or 2, and the C can only be in seat 1 or 2, and therefore the M must be in seat 3. Okay, I'm making slow progress. Here we go. So now that we know that meatloaf is in seat 3, Zach cannot have meatloaf. Let's see. PW, P, and ATDC. Zach cannot have C because C is in seat 2. Okay. Zach sat in a seat number 2 higher than Canapes. Now, Canapes is starter C. We don't have that yet. Okay, so we don't know that yet. Oscar ordered quiche. The bundt cake was ordered by the is 3 higher than cottage pie. So D is 3 higher than C in the mains. Okay, that's also 2 possibilities. Yeah, Nadia sat right in. Okay, Amandine is in 3, 4, or 5. And Nadia is therefore 2, 3, 4, or 5. And Nadia cannot be in seat 1. And if Nadia is not in seat 1, then Nadia cannot have the salad starter or the brownies dessert. Yeah, I think that's it. The person in seat 1 ordered salad. So I have this rule down pat. So I'm going to gray this out. Let's make that point 2. There you go. Petra ordered noodle soup. I have that written down up there. So let's do that. That one also. Did I put 2 different values? Okay, there you go. The meatloaf eater, which is a main, right? Yes, it is a main. Sat in a seat number 1 higher than cottage pie is also a main. So M is one higher than C. And we already know M, so C is here. So this is the C and this is the S. Perfect. So so none of these can be in seed 1, and therefore none of them can have S. Okay, we already know that. Zach is P or W. We already, wait, oh, these are starters, I'm sorry. Ah, it's this one here, okay. So Nadia is not in seed 1 and can therefore not have S as the main. Yeah, I think that's it. Zach sat in a... Okay, so Zach is in 4 or 5, which means Brownies is in 1 or 2. But Brownies cannot be in 1. So Brownies is in 2. I hope I got that right. This feels... okay. So therefore, Zach is in seed 5. That is now the only seat left for Zach, which means none of the others is in seed 5. And seed 5 can only have P or Q as a starter, not W. So Zach has the P starter, which is in seed 5, and therefore this is the Q starter and this is the C starter. The Q starter is in seed 4, so this is seed 4. So Oscar is in seed 4. Zach has the P main, so this is P, and therefore 4 is N. But N is Petra. Okay, I made a mistake. Did anyone notice my mistake? Did anyone notice my mistake? If not, I'm going to have to start over because I have no clue where the mistake was. Okay, I'm not seeing a response. Okay, well, I guess we're gonna start over then. Seed 1, 2, 3, 4, 5. Here we have CPQSW. Here we have N. We have C. MNPS. And then we have ATWC. Okay, and then we copy all of this to here. And then we start over. Zach sat in a seat number 2 higher, well, also 3 higher, right? So Zach is 4 or 5. Then the person who had Brownies, so Brownies is 1 or 2. Brownies is a starter, so the other seats cannot be Brownies. And also Canopies, which is also a starter, must therefore be in 2 or 3. So it's not in 1 or 4 or 5. Oscar ordered quiche, so that is quiche. All the other ones are not quiche. The bundt cake, so D, was ordered by the person in a seat number 3 higher than cottage pie, which is C. So C main. Okay, so first of all, bundt cake is 3 higher. So the D has to be one of those two. And then the cottage pie, which is a P main, is in those 2 spaces. Nadia sat directly, and we'll get to that later. The person in seat 1 ordered salad, so seat 1 is the S starter. Let's move those over. Petra ordered noodle soup, so Petra is noodle soup is a main, yes, so that is N. The meatloaf eater, which is a main, is 1 higher than cottage pie, which is also a main. So that can't be M and that can't be C. Zach, did anyone respond? No. Zach sat in a seat number 3 higher, we already have that, but it means that Brownies brownies are 3 lower than Zach, so it's 1 or 2. So these are not brownies. Whoops, like that. This is what I wanted. The salad eater. Salad is a starter. The salad eater sat in a seat numbered 1 lower than the person with churros. Churros is a dessert, therefore churros is in seat 2. Salad is a start, yes. So churros is in seat 2. Like that. Okay, that leaves only seat 1 to have the wings. Wings? No, we're talking about brownies. Wings, okay, wings is actually also, there's only, wait, why? How did I rule out wings? I think I removed the wrong, yeah, I removed the wrong W, didn't I? Yeah, right here. Gosh, now I have to start all over again. Okay, Jesus, I really need to pay more attention to which one of the W's and C's and S's. This is so annoying. I really don't like Einstein puzzles. But I'll do it. I will continue. Zach is 2 higher than canopies, so canopies, which is a starter, canopies, must therefore be in 2 or 3. Right, that's 2 less than this. Oscar ordered quiche. That's here. Yes, quiche is a starter. The bundt cake, which is D, was ordered by the person in seat number 3 higher. Nope, that's that one. 3 higher than the person with cottage pie, which is a main. So cottage pie is in 1 or 2. Nadia, ignore that. Person in seat 1 ordered salad. Salad is a starter. So this is where the salad goes, and all of these salads go away. Okay, this one is definitive and can be that, and this one also. Petra ordered noodle soup. So Petra ordered noodle soup, which is a main. So it's the N here. Yeah, so that goes away, indent that, remove the N's. So that was Petra. The meatloaf eater is 1 higher than cottage pie, and meatloaf and cottage pie are both mains. Meatloaf is 1 higher than cottage pie. Cottage pie is already down to C's. Did we actually have cottage pie earlier? Yes, we had cottage pie here. Okay, so meatloaf is 1 higher, and therefore one of those 2. Zach sat in a seat number 3 higher than a person who had brownies. Now, brownies is a dessert, and since Zach is in 4 or 5, it means that brownies is 1 or 2. There we go. The salad eater, salad is a starter, sat in a seat 1, which is 1 lower than churros, so churros is 2. Churros is a dessert, so it's this one here. So let's put the C here and indent everything else. So now brownies can only be in seat 1, right? I think that's right. So brownies are in seat 1, which means that that Zach cannot have brownies, cannot have cannot have C or M here for the mains, and can also not have N because N is already Petra's. And then this has to be P, Q, or W. And it's not Q because Oscar is already the Q. Okay. So far so good. Whew. I'm like super paranoid that I'm making another, dumb mistake. The person who ordered spaghetti, which is a main, sat in a seat 3 lower. So that means that is 3 lower than someone else's. Then the person who ate prawn cocktail, which is a starter. So if If spaghetti is in 1 or 2, then prawn cocktail is in 4 or 5, and therefore not in 2 or 3. So P goes away. So at this point, we can see that the cottage pie and the spaghetti are shared between seats 1 and 2. Zach also can't have churro. Zach can't have the dessert churro. Yes, thank you. Okay, so C and S, the mains, right, cottage pie and spaghetti, are shared between seats 1 and 2. So these go away, and that leaves only seat 3 for meatloaf. So I claim that this is the correct arrangement. So that means that Zach cannot have meatloaf. We already knew that. Okay, but we know something else about meatloaf. It's 1 higher than cottage pie, and cottage pie is the C. So this is the C, and this is the S. Okay. Yeah, so that leaves noodle soup and pizza as the mains for 4 and 5, which means that Zach can no longer have the spaghetti. Because spaghetti, I'm just checking it now for confirmation. The spaghetti is 3 lower. Yep. So Zach could not have had spaghetti. So Zach has the pizza. So the pizza is nowhere else to be seen. Okay. Zach sat in a seat 2 higher than Canapes. Canapes is a starter, and that starter is in 2 or 3. We don't know this yet. The bundt cake D was in 4 or 5, which is 3 higher than cottage pie. Cottage pie is therefore 1 or 2, but we know that cottage pie is 2, therefore the bundt cake is 5. Yeah. And therefore, I think we can take that out. Because we have the seat for bundt cake and for cottage pie now, right? Cottage pie is a main. Yes, we do have that. Okay. Meatloaf is 1 higher than cottage pie. Meatloaf, cottage pie. Yes, we have that. Welcome back, Penzo. I'm going to need a hint on the science puzzle, the, what was it called? The, solidary task, but let me continue with this first. I need to concentrate very hard on this because I'm not good at Einstein puzzles. Zach is 3 higher than brownies. Now we know that brownies is 1, therefore Zach is in 4. Yeah, therefore Zach is seat number 4. There you go. And if Zach is in seat number 4, then the starter cannot be quiche here. The main is actually P, and that is N, and then this is not a D. So Zach is 3 higher than brownies, and we know the seat numbers for Zach and brownies. Okay, opacity 0.2. The salad eater, which is... No, salad is a starter. Yes. The salad eater is 1 lower, so in seat 2 we have churros, and churros is a dessert, so we already know this. I'm sure I already did that last time around. The person who ordered spaghetti, now it gets interesting. Spaghetti is a main, is 3 lower than prawn cocktail, which is a starter. So this here is 3 higher than this. No. Yes. So, therefore, prawn cocktail, which is a starter, is in seat 4. Do I correct? I think I do correct. So, and since we know that Zach is in seat 4, that means he has the prawn cocktail. And there we go. So, the person who ordered spaghetti... I concur. Okay, so the person who ordered spaghetti, which is 1, is 3 lower than a person who ate prawn cocktail, which is here, because that's a starter. Okay, so I think that this is also done, which means that it all rests on those two. Do we have canopies yet? No, canopies is a starter, so it's one of those two. But we know Zach. Zach is 2 higher, so canopies is actually in seed 2. There we go. So that is either quiche or wings, and that is either quiche or wings. Bingo. So that is also done. So Nadia sat directly next to Amandine. Now Amandine is a dessert, so that's in 3 or 4. Therefore Nadia is somewhere between 2 and 5, but not 1, and also not 4. Ah, she can't be 5. No, she can be 5, because then Zach would just get the Amandine. But she can't be 2. Yes, she can be 2. Can she be 3? Yes. Okay, so I'm not quite sure. I've already used the P here. So I'm gonna have to cross-pollinate here. So Nadia is in 2, 3, or 5, which means that her starter... Wait, quiche is in... No. Yeah, quiche is either in 3 or 5. So this is not 1 or 2. And wing. So CS and wing cannot be in seed 4. Yeah, no, that's we already knew that. Let's see. N is in seed 5. So Petra is actually in seed 5. Nope, no, don't do that. Okay, so that leaves seed 3 for Oscar, seed 2 for Nadia, and seed 1 for Esther. And Nadia is next to Amandine, so Amandine must be in seed 3. So this is A, this is T. Right, but we know that Zach is in seed 4, so Zach had the T. Seed 5, the starter cannot be, like according to this here, cannot be quiche, because quiche is, in fact, much easier, quiche is in seed 3. So that's just the Q, that is the W, and now if I just put the people here, then I have it all. That's Esther, that is Nadia, then that is Zach, Oscar, and Petra. But because these are not in alphabetical order, I'm going to reorder this. There you go. Now, the total cost, I assume that these are indexes into these, so I need to write them out. So we have wings. Wait, hang on. So why are these not alphabetical? The fact that it says seeds 1 through 5 here, this could be seen as a red herring, right? If it says seeds 1 to 5, I would assume that those seed 1, 2, 3, 4, 5, but you know, we now know that that's not the case. But also, you know, seeds 1 through 5 kind of suggests that you should order by that, because it's a numerical thing and they're consecutive. But I'll just try both. It's fine. So we have, let's see, we have canopies. I should do this in all caps. We have prawn cocktail. I'm gonna just write prawn because it's only we'll get to it when we get to it. This is salad. This is quiche. And then the mains are meatloaf. P is pizza. Spaghetti. Cottage pie. And noodle soup. And then the desserts are, so D was bundt cake. This is brownies. This is churros. This is Battenberg. And finally we have Amandine. Okay, now Petra is 283. Let me reduce the font size here so I can still put 3 letters here. So 283 is 283 ion. Okay, so maybe we are sorting by this, the seat number after all. We have 595, 5, 9, 5, 5, 9, 5, 5, 9, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5. And then Nadia is 374. 374. Zach is 156. 156. And finally, Oscar is 462. 462. And now we sort by seat. We get dinner companion. Yay! Awesome! Yes! Okay, I did an Einstein puzzle, which is not usually my strength. Okay, so Penzo, I would like a clue on this. So what I said while you were gone about this is that each of these, where it says 1, x and y, reminded me of these kinds of puzzles where you have, for example, 21p on a D, and it's 21 pips on a die. Team. There you go. Now read the first letters of the different... Oh. That's why they're in this order. I see. I didn't even notice that. Good job for noticing that. Very good. So, am I on the right track? Is it like there is one, anion neutralization of H3? I don't know. Is it something like that? And each of them is from each of these topics. Contemplate unity. This feels really difficult. You're on the right track. This is why I said this was the hardest puzzle for me. I'm afraid it's gonna be hard for me too. Also, interestingly, you said that this requires knowledge in science, but science is only one of these 7 areas. Wait, hang on. 1, 2, 3, 4, 5, 6, 7, 8. But there are only 7 here, which means that the big one is the 8th one. Okay. Sciences. Oh yeah, like literature is a science, right? And okay, well, recreation. That's the most sciencey one. No, okay. I think I might need a sort of general hint. So are you saying that I am correct that each of these is the first letter of a word, and then this will make a phrase that says there is one an of h something? It just occurred to me that the subscripts may actually be indexes and not enumerations, as I suspected. Let me just, for posterity, put team. Here. There we go. Okay. And then dinner companion is the answer. Okay, so back to here, I guess. Yeah, you're correct. Or like 1 is. Oh, 1 is. 1 is. Okay. So LNTYED. This seems like a phrase. So I'm going to lowercase that, and I'm going to change this to that, like this, and then do this. Let's see if Nutramatic will tell me what this is. Oh, oh, why did I close this? Jesus Christ. I have a, what's the word? A muscle memory to just close tabs. Computation limit reached. Come on, come on, come on. Yeah, okay, so that's not it. But maybe one look knows. Maybe if I change these to that and then not have that. No. Okay, well, let's see if I can find some of this. Lasted nearly 2 years. ED. Okay, let's see what happens if I do this. Lasted nearly 2 years earlier during. The Yongzheng Emperor died. Yeah, okay, it could be this could be a lot of things. The youngest ever something. LN. What did you say it was? One is the I don't know. So astronautics is obviously space travel, so like the first man on the moon or something would make sense. That would be Neil Armstrong. I would honestly suggest doing the other puzzles first, but I'll have to get back to this puzzle at some point. But okay, I'll take your advice. The Turing task. Prove that you're half human and half computer. Easy, because I'm just a... Okay, I am a computer, but I'm just about able to pretend to be human. Select the 10 squares containing redacted. You don't need all 12 puzzles of the meta, but I do want to solve all 12, or at least attempt them. At least having... I want to have given each one a genuine go. Okay, so let's close this. Let's see. Are these individual images or is it one? Oh, it's individual. Very good. That makes it very helpful. So, I think I'm just going to write down the results I get here. So I have Amumu. Wrong. This is what I want. Kled. Are these all League of Legends? Poppy. Heimerdinger. And Tristana. This is one of the Powerpuff Girls. Bubbles, apparently. This is Mojo Jojo. Also from the Powerpuff Girls, apparently. Yeah, these are all from the Powerpuff Girls, aren't they? This is Professor Utonium. I don't know if I should put Professor in front there. I guess the alphabetization might reveal that. Is that person called him? Because then the alphabetization is off. Oh, this is also not alphabetized. In which case, okay, I'm just gonna assume that this person is called him. That's just an image. This doesn't even tell me what the name is. Let's open this, I guess. And, there you go, it is him. That is the article title. Him. Well, it doesn't matter which one of those it is him. And then finally we have Buttercup. Yes, it's Buttercup. Who is this? Is this, what's it called? Street Fighter, thank you. That's what I meant. Cammy, apparently. It's so weird, they're like almost in alphabetical order. Yeah, I think that's Ken. And then we have Akira. Yeah, it seems that they're all in alphabetical order except for this column. No, wait, that's not right. Buttercup. Okay, Rose. Yeah, so again, these are in alphabetical order except for this. These are in alphabetical order except for this. And these are completely off. Regardless of whether I put Professor in front here or not. Alright, these are probably characters from a sitcom. We have Lavender Brown. We have Ivana Lynch. We have Ginny Weasley. Oh, this is from Harry Potter. Are they all from Harry Potter? If this is Umbridge... No, it's... Okay, Petunia Evans is also a Harry Potter character. And this one here looks like the Hogwarts uniform, so... Scholar. I don't know this character though. Burn. That is an actress. Pansy Parkinson is the character. Yes. Pansy Parkinson. So let's quickly check if this is a character or a... this is an actress. Okay. She's best known for portraying Luna Lovegood. That is definitely a name I've seen before. Lavender Brown, gonna assume is a character. Yes, it is a character. Okay. Next. We have this. This looks like anime. Gardenia. Whoa. Sylvana. Which one is it? This one says Gardenia. Okay, fine. Let's open this one, and these are the only two that have a name, and this one has Sylvana in the title. This one here is just a DeviantArt page, so I'm going to trust the PokeWiki and say it's Sylvana. Then we have Iris. Then we have Misty. And then we have Flannery. And then we have Tulip. I'm gonna assume that the name of the character... Oh, Jesus. That is the right image, though. Okay, it does say Tulip there. Okay, I don't know why it says forbidden, but whatever. You know what? Why don't I do this? Tulip, Pokemon, images. Yeah, that is Tulip. Okay, we are good. So that is my first block of thing. Select the 10 squares containing redacted. And then select the 12 squares containing redacted. And here we go again. Search. That is the Magician. I assume that these are all tarot cards. Death. That is a queen. Empress is what it's called. This is a priestess or something. That is Temperance. And then we have the sun. Yes, it's the sun. What are these? These are boy bands or musicians? That is King. Is King the name of a band, or is Paul King the name of a person? Let's search for the whole thing. Love and Pride. Okay, I'm gonna assume that. And that sounds like a name of a band. And also it's listed twice, and why it still says mostly King. Why is this translated into German? Okay, well anyway, let's move on. This is Bon Jovi. Is there an easy way to just get it to just select the whole thing so I don't have to do this drag and drop thing? So this is the second one, that is John Bon Jovi or Bon Jovi, I don't know. Just gonna write this because that's the name that I know. Freddie Mercury, which is Queen. I know where Freddie Mercury is from. That is the Monkees. And that is Prince. The artist formerly and then again known as Prince. Or is that a different Prince? I don't know. Let's keep going through this. This is a... Oh, this is one of the cards from Love Letter, I see. Or is it? I mean, I see the number in the corner there. That seems... Big box. Let's click on this and see what happens. It is Love Letter. So maybe... there we go. It is the Gardes. How do you say this in English? Is this page... hey, maybe I can just remove the DE there. No, that's unfortunate. Why? Can I just have the same thing in English, please? I hate that Google keeps giving me German stuff and there's nothing I can do about it. Let's see what I get if I click this. This is annoying. Okay, I have an idea. Love letter card names. Okay, which one of these is most likely Wächterin? In fact, I could just look at the number. Right, it's number 1, so it's the guard. Why would they specifically make that female? But that's okay. I don't mind that. I'm just it's just curious that they decided to do that. We have a again, it says German everywhere. Okay, so there's a guy with a rose in their hand. Let's see who that is. None of these. Oh, there we go. Okay, here's the male guard. Okay, so maybe I should remember that that is from the female set. But also, I'm not seeing the guy with the rose in the hand. Am I not paying enough attention here? Ah, there it is. It's the Baron. I'm also gonna put the number of the card there, just in case I need that. Then we have... okay, so that is the handmaid, isn't it? Zofe. Yes, that is the handmaid for female. So what is the male equivalent of the handmaid called? I'm just curious. Maybe I'm wrong about them being a male and a female set. Yeah, I see. This is just a extended set. Yeah, it's not about males and females at all. And none of these have come up yet. Okay, so I'm going to remove that again, but keep the numbers. Okay, then after the handmaid, we have, that looks like it could be the princess or the countess. Oh, there we go. It is the countess. Countess, number 7. And finally, that one. Oh, that is actually the princess. Okay. Alright, next set. We have some species of butterflies here. So, I am probably going to have to look up the scientific names. It says gatekeeper there, so I think that's probably it. Yeah, it's the gatekeeper. I didn't know there was a butterfly called gatekeeper. You live and learn. Swallowtail. This is a viceroy or monarch. How do I know which one? It says monarch here, but that is not the exact same image. But then nor is this. Yeah, most of these results say monarch. I hope I'm not making a mistake by removing viceroy there. This is the painted lady, apparently. Okay. And this purple one is a lesser purple emperor. Huh. Prince, princess, empress, emperor. Okay, lesser purple emperor. Okay, finally we have this one, which is blood marquis. I hope that's right. Yeah, everything says blood marquis as soon as I select the entire image. Then we have Mojo Dishu. Let's see. Oh, there's another one, but that's not the same character, right? That's this one is the right one, as the exact same image. Okay, then we have this one, which is the Eternal Traveler. Okay. Death's Advance. Duchess Minx, maybe that's more likely. Let's scroll down a bit. Let's actually select the whole thing again. This is a category, but this one is not the same image. Let's click on this and see if I can actually find it in this category. So if it is Minx, Duchess Minx, then the image should be in this article, and indeed it is. There you go. So it is Duchess Minx. Again, Duchess, Countess, Queen, these all seem related. Finally, we have this one here, which is Count Nefarious. Okay, I hope, Penzo, I hope you're still here, because, can you just confirm that I've got all of them right? Okay, 10 squares containing redacted. Well, poppy is a type of flower. Tulip is a flower. Rose is a flower. I think buttercup is also a flower. Lavender is a flower. Why does it keep doing that? And iris is a flower. 1, 2, 3, 4, 5, 6. Petunia, 7. Cami should be lily, and Silvana should be gardenia. Okay, this is lily, which is also a flower, and Silvana should be gardenia, which is also a flower. Okay, how many do I have now? 1, 2, 3, 4, 5, 6, 7, 8, 9. So one of these is a flower that I don't know. Silvana is the German. Thank you. Yes, as I said, you know, Google always gives me the wrong one. Okay, so one of these is probably a flower. Let's see, is it Ginny? Is it Misty? Is it Akira? No, probably not. Can I? It's so bad. Amumu. Okay, Akira is not one. Amumu. Okay, it's some town. Pansy. Aha, the pansy is a flower. It's a type of polychromatic large-flowered hybrid plant cultivated as a garden flower. Okay, so you know what I'm going to do? I'm going to go here and create a tab called Turing. That is the Turing, yes, it is the Turing. And then I'm going to create conditional formatting where the text starts with a square bracket. I'm going to make it like this. There we go. Okay, now let's do this. Do this. Okay, that, and that. And then let's also do this, by which I mean this. Okay, some of them still don't fit, but I have way enough space on my screen. There you go. Okay, so I've selected the 10 squares containing a flower. Now, 12 squares here contain a, you know, a rank of the peerage, or, you know, nobility. So prince, princess, emperor. Let's put that at the start. Duchess, count. How many do I have? 1, 2, 3, 4, 5, 6, 7, 8. Also, Love and Pride is the song, King is the band. Thank you. I mean, I could have guessed that now that I know that it's about nobility. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2 more. I guess the Marquis is kind of like a Marquess or Marquis is a nobleman. Okay, we can deal with that. So 1 more. Let's see what a mojo dishu is. That could be a Japanese, no it's not. Oh, baron, I completely missed that. Okay, so I have selected them. So now, let's see, this has a height of 5 and a width of 5. So I suppose it could be binary. I was going to say Braille first, but that requires a multiple of 3. So this is a D, A, 2, 4, 8, 9. Oh, this is going to be Daisy, I can already tell, because the last two are very high numbers. And then this is D, okay, 1, 2, 4, 8, 16, that's 21. Oh, Daisy Duck? No, it can't be Duck. That is 3, that is 11. That is almost Daisy Duck. 1, 2, 4, Daisy Dukes. 1, 2, 4, 8, 16 plus 3, yes. Daisy Dukes. Maybe Daisy is wrong. Maybe I judged that too soon. Nope, it is correct. There we go. Ladies and gentlemen, we've solved this. It's Daisy Dukes. Let's make that centered and bold and put it here. And that is Turing. Yep, a Daisy and some Dukes. Okay. Then we have the veterinary task. Let's actually put the remaining task names here. Zoological, I'm already looking forward to zoological. And I'm not saying that because I saw that it's a crossword. I'm just into zoology. Find what's wrong with these cats. These cats. Okay, these cats. All right, let's find out what these cats are. That seems to be a shop, a coffee shop, maybe a cafe. I'm gonna go with cafe on this one. Let's do this. Veterinary. Boing boing and bitter. Cafe is what it was. Okay, that one I need to search. I don't know who that is. Clint Eastwood, perhaps? Oh my gosh. The only reason I guessed Clint Eastwood is because I watched Back to the Future 3 just a few weeks ago. Clint Eastwood. That is obviously pizza or eat. I think it's supposed to be eat. It's definitely not a hot dog. Yeah, no, I'm gonna go with eat on that. That is a jacket. That is a mouse. It's actually a rat. That is a crib. Cradle. Cradle. So again, not alphabetical. The only reason I said eat is because, I assumed it would be alphabetical. Okay, what is this? What is this? King's College? No, it's not King's College. Kana Catholic Wedding Church. Okay, this is probably just church. I can't tell what this is. Is that a bucket or something? I hate this so much. Why doesn't it just select the whole thing? It's a yogurt machine? A hygiene product? I don't know what that is. I'm gonna put yogurt machine, but I don't know why something so specific would be in this puzzle. This is not Mao Zedong. Most certainly not. Yeah, that is the same image. Kai Hessen or Hessen, I don't know. Close that. And finally we have a piece of pizza, so that could be referring to crust. Okay, so I think it might be crust. Find what's wrong with these cats. Cat in the cradle. Okay, yeah. What do you mean what's wrong with these cats? Cat crust. Let's see what happens if I Google for this with cat. Yeah, this doesn't really mention cats. I suppose if it turns out that it's actually Mao Zedong, then Mao is, you know, the sound that a cat makes. As in meow, but Mao. So I don't know. Penzo, are you still here? You say this was funny, so I need to turn on my humor. Okay, am I on the right track with cat in the cradle or cat and the cradle or something? Cat cradle. Yeah, cat's cradle. Lol. That's not the right track. Okay. In that case, I don't know what this is about. Is this about some interest of yours that I would need to know about? Some, you know, some prior knowledge? Or maybe you can confirm if I have all of these correct. Wait a second, I think these might be intentionally placed in yes, these are specifically placed in two per. I think you identified some correct things that could be a good starting point. Wait, you're saying that most of them were wrong? Okay. So anyway, I think I want to arrange them like this. That and that. Eat jacket, rat cradle. I mean cradle. I mean cat's cradle, rat's cradle is one letter away, but what did you say? You identified some correct things that could be a good starting point. Okay, again, give me the good starting point. What's wrong with these cats? I mean, there seems to be a high abundance of things that start with C, and these all end in AT. The yogurt machine could be a vat. So in order to turn this into cat, I would have to replace the FE with a T. And if this is just Clint, then that would be Lin. And then here we have ER. And then if this is just Kai, then that would be an I. And then this would be Russ. If this is a vat, then that's a V. If that is a cot instead of a cradle, then it's an O. That could be a coat, in which case the O just goes away. And then we need another word for church or specific. Oh, I closed Chrome. Did not mean to do that. Let's open this again. And let's search this again. Kana, of course. Okay, so that is kana, which means this is na. Okay. Vat. Not sure about the code because it's ambiguous, but it is absolutely a code. Hello, Finder. Okay, so what what other words are there that mean jacket, not hacket? Not hacket, jacket. Coat. Case. It's probably not that. I'm gonna assume that it is coat. So I just realized that if you add an E here, you get feline. Feline coronavirus. Okay, if you replace the co with a C, okay. Feline coronavirus. I didn't know that was a thing. Yeah, okay. Okay. So, bold. And here, that is uppercase that. And finally, we have zoological. Okay, is there a copy and paste to do the grid? No, there isn't. Okay, so copy the image, make me a tab, put that here, call it zoological, make everything, let's see, resize this column to 30, resize this column to 30, and then insert columns like that. And let's recreate this. Let's go. Okay, so I think I can get away with significantly bigger things, so I'm going to make it 47. It's a nice size. Resize these to 47. And move this over to the left a little bit. And then let's start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm going to start here. Let's start with the, yeah, let's just, okay, all borders, like that. Okay, there you go. So boink, boink, boink. So that is a 7, just chilling in the middle of nowhere. That is where the 9 goes. So 9. Let's also align top and left. Okay, let's do the borders again. That, and that's a 1. And then that, and that's 11. And at this point, I think, you know, I'm to unconfuse myself, I'm going to resize this to match the size of my spreadsheet so that I can eyeball how it all fits together. Okay, so then we have this 1, 2, 3, 4, 5, and that's a 12. That is a 4. And then I messed up because all of this needs to be here, and then yeah, this is correct now. And then we have this, and then we have this, and that's an 8, and then we have these and this, and that's a 3, and then we have that, and that's a 2, that's a 5, that, not what I wanted. Okay, the 5 is still correct. That is a 6, and that. So, that looks good. And now, to make it look nice, I am actually going to do the effort, because, you know, I am like that. 6 should be 1 to the left. The 6 should be 1 to the left. Thank you. Thank you. All right, that and that. 2 and 4. Okay, let's go here. 1, 2, 3, 4. 1 and 4. 2, 1. Undo that. There you go. And then this. 1, 2, 4. 2, 3, 4. 2, 4, 4. 1, 4. 3. 2, 3, 4. 1. 1, 2, 4. 3, 4. Except not that one. 3, 4. 3. 2, 4, 1, 3, 4, 1, 2, 3, 2, 3, 4, and 4, nope, 3, 2, 4, 1, 3, 4, 1, 2, 4, 1, 2, 3, 4 and 4, 1 and 3. Okay, I think I have them all. So I think I can get rid of this now. Yep. Okay, let's move that tab down 1. Okay, it's a bit annoying that these blocks are not Unicode characters, so they don't copy. That is quite annoying. But aha, here's what I can do. Okay, so this is, yeah, okay, so I can actually just copy the HTML, do this, replace all occurrences of this with this, and then plug it back in. Nope, wrong, that is not what I meant to press. This is what I meant to press. There you go, plunk. And then I can copy and paste it. Animal that goes, ooh. Blob space. Okay, I can do that. Replace that with this. Oh, no. I need to replace that entire string with that. So let's try that again. Go here, select that, put that in there. Yep, and there we go. And now I can copy that into here. Perfect, perfect, perfect. I'm going to move it up 1. I am also going to, yeah, okay, let's change this to a proper font. In fact, let's change everything to bitter, right? But let's also make this top aligned. No, let's make it middle aligned. Let's also make this middle aligned. I'm probably going to change these cells as well at some point. Okay, what does the fox say? What does the dog say? What does the 6 misspelled? Ooh. What does the... Okay. Google Sheets not defaulting to Milward makes me so sad. Yes, and I suspect that literally the only reason it doesn't do that is because it tries to maintain compatibility with Excel, and Excel in turn maintains compatibility with, you know, older Excel. So it goes all the way back to the 90s. Okay, so this seems very open-ended. Demonstrate your knowledge of bioacoustics. So unless this is a reference to the Ylvis song, I don't know how else to proceed. So let's look up the lyrics of The Fox by Ylvis. And here we have dog goes woof. So dog would fit here, and then woof would fit here. So let's insert a column and say dog goes woof. And then cat goes meow. And then bird goes tweet. And the mouse goes squeak misspelled. But it is 6. I'm not quite sure how to misspell that. What does the cow goes moo? The frog goes croak. 1, 2, 3, 4, 5. Yep. And the elephant goes toot. Elephant toot. What do ducks say? Quack. Then we have fish go blub, which is not really something they say. It's rather a sound that the water makes. And the seal goes ow, ow, ow. Let's extend that a bit. Let's also extend that. Let's actually do that. But there's one sound that no one knows. So we now want a... Is this basically the same thing again? Animal that goes woof is the dog. And then animal that goes meow is the cat. Let's see if that fits. Dog, cat, bird, mouse. Yeah, sick is once again referring to a misspelling. Weird. Cow, frog, elephant, ducks, fish, seal, seal. Right, okay. So I think that's it. I think I'm literally just putting that there and that there. Okay, it just occurred to me that this misspelling might actually be in the actual video, because I know that Ulvis always put wow, it's not in my list. It's not in my browser history, and it's not here either. Oh, what the heck? Am I stupid? It's a different song. This is the one, right? They always put these subtitles that are sort of, what's the word, burnt in. So let's take a look. Can you guys hear the music? I think you probably can. Okay, already too far.
Dog goes woof, cat goes meow, bird goes tweet, and mouse
squeak. Okay, they misspell it with a double E. Okay, that makes sense then. All right, so we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. I believe that elephant is the only 8-letter thing. So let's do that. I'm going to make this centered, middle, size 48, as a bit much. 24, there you go, bold. Maybe not bold. Right, and so how am I going to do the numbers? You know, I'm tempted to put those numbers. Yeah, I'm going to do this. Okay, so this is 9 bottom. There you go. And then this is middle. And then this here is 11 bottom. 11. This is a 4. Let's do that. This is a 12. This is 8. 3. 2. 5. 6. And finally 7, like this. Okay, I think that is a lot more doable. Now 10 goes here, bottom center, like that. And now I can, yeah, okay, so all except these are going to get the formatting. So I want them size 24, centered, middle, and bitter. Okay. So what has an E? So I think I can probably get rid of all of this because I have all of the words here. And then I can use this to just mark them off as done. Right, and then I'm going to open up a conditional formatting thing, because then I can use a custom formula to do regex matches. So here I want something that ends in that. So we have tweet, squeak, and yeah, tweet and squeak. So tweet doesn't fit, so this is actually squeak. So let's put that there. Let's also center these. And then we want something which has that. That would be blub. That can only be here. Something ending in K. That is a lot, but we want 5 letters. So 1, 2, 3, 4. And still 2 possibilities. So there's an R or a U. So let's see if we can find something that is dot dot and then RU and then dot dot. This is case sensitive. That is a mouse, which means that this is quack. And then we want this one here, which is dot E dot dot. That is either meow or seal. Okay, we need something ending in S. That would be ducks. That is indeed the only one. The only thing that ends in D is bird. The only thing that ends in K is croak. Now that squeak is used, is taken rather. This must be, no, it could be cow. Something starting with O. That is obviously ow, ow, ow. Something ending in W. That is meow. Can we like... no. I don't think I need this anymore, right? So I think I'll just remove the rule. I can always rewrite it. So I think this is meow. This is the moo. And then this has to be the cow, which makes this the cat. Doink, 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 doink. Cat and cow, yes. And then here we have the seal is the only thing that fits here now. Then something ending in S is obviously the fish, which is here. We have only one 3-letter thing left. That is the dog. Ooh. I messed up somewhere. This has to be the frog. Okay, I messed up. So something that starts with T, that would have to be tweet. And then this is woof. And then this is toot. Cow and dog switch. That would still not fix it. But that's a good point. The dog could go here, but we need something ending in T here. So this would have to be the cat. I get it. This is the cat, this is the cow, and this is the dog. Yep, got it. Thank you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I should have just done that. And then let's give these that formatting, but not with a border. Let's actually do this. Okay, so number 4 is an M, number 11 is an I, 12 is an A, 10 is an E, 9 is an O, 1 is an O, 7 is an O, 3 is an O, so many O's. Onomatopoeia! There we go. Okay, check. Hello? Can I... Is the check your answer thing not a link? Yes it is. Why is it not work? And now it works. Okay, that is correct. There we go. So let's go here. Let's replace all the new lines and put that in. Okay, that leaves solitary and reconciliation. So with your permission, Penzo, I would like a hint on this so that I can start on this puzzle. Or if anyone else wants to take a guess as to what's going on here. Thank you, Procyon. So what we had was, you said it's one is, here, one is. So one is H on a DC, but not on a BC. Middle line has an isotope of uranium with negative... Yeah, well, I will say I backsolved this one, so if you solve this forward, you out-power scale me. Haha, okay, so you don't actually know how this works? Did you not ask the setter? Contemplate unity. Contemplate. Yeah, I don't think that's an extra hint. I think it's just saying that everything is about things that come in ones. I know how it works, but I could only do it halfway. Well, but that means you can help me with the ones. You can help me get started, and then maybe I can... Okay, let's ask this way. If you did tell me, you know, if I did figure out the same ones that you did, does that help me with the others? Or are they all isolated from one another? This could genuinely be anything, like one, they're all isolated. Yeah, that's unfortunate. One is the last nematode or whatever that you ever discovered. You know, it could just be that, and All right then. Well, you seem to be quite vocal about me that I shouldn't do that. So I think I want to finish this. So if you can figure out another step here, Penzo, since you're back, we could continue this or we could back solve. But I really want to do this puzzle. I think this is really cool. I want to know what the remaining deductions are, and I want to get better at yin yang. See, this one here is half black and half white, so that helps very little. This one here is almost entirely white. I mean the edge. So the black has to be kind of a maze, or two mazes, right? One maze emanating from here and one maze emanating from here. That is still quite ambiguous, but So Penzo, is it like reasonable to ask of you to give me more tips, or would you have to like basically resolve this at this point because you don't remember how it worked? Which is fine, of course, I'm just asking. Everything you have so far should be correct. I'm looking for a deduction. Thank you. Appreciate it. Alright, I'd have to resolve it, yeah. I will say if I see something, everything, yeah, okay, yeah, thank you. So I think I'm going to put a hypothesis here, because that requires that, and then it requires that. And then I'm stuck again. Great. I think that the next deduction deals either with the fact that one of these two has to come out, or with the fact that one of these has to be black, and that does something to the border. So hypothetically, if this one is white, then it would require all of this to be white. And then we get quite a lot of black here and here. And then that as well. That has to come out, so that's also black, which makes that black. And then that has to come out, and then that is a white, which makes that white. You have something. Okay, cool. Let's do it. Go ahead. Give me your deduction. Or rather, give me, a place to look at. Check the purple bar, the second cell specifically. Huh. The second cell. The purple bar, the second cell. Okay, so if that is black, it requires that to be black, and that makes two blacks here, and then that is white and white. And we have a checkerboard, and it's bang, yeah. So that is actually white. So let's make that white and that white. Well. Oh, so you're saying the first cell will also result in something. Okay, so if that is white, then that is white. That doesn't mean anything. If that is black, then that has to be black. Oh, there you go. Yeah. Okay, I don't even need the purple for this, right? The fact that these are both blacks means that one of these has to be one of these has to be white, but you can't have this because of the checkerboard. Therefore, the white one has to be this one. Bingo. Okay. And now that is black, and that is that. I saw the deduction in the left grid, but right grid works too. Oh. Oh, okay. So this black has to come out, and it has to come out big time. There you go. Yeah, okay, so let's put that there. And then we have this checkerboard rule. Okay, so now we have these two blacks here, which means that one of these two has to be white, which means that these have to be white, which means the black has to come out, has to prevent a checkerboard. That is a 2x2, that is a 2x2, that is a checkerboard. Okay, so one of these is white, and one of these is black. Yeah, that doesn't help us anymore at this point. But, wait a second. This little piece of black here has to come out of this. So all of this has to be black. That has to be white. And then these have to be black because one of those has to be black. So that is a 2x2. And that, no, we already transferred all of that. But, nope, we cannot deduce that either. Oh, but here, this entire shape has to come out. But that doesn't really help much either. Jesus. But here, this is now closed down. So this black shape has to come out through here, which puts a black there, which puts a black there, and that's a 2x2. The white has to come out here, and then it can't form a 2x2. And then we're making good progress. Let's see. So, this is a really cool concept. Yes, I agree, Procyon. This is absolutely amazing. This is fantastic. I'm enjoying this so far so much, and the entire hunt really. Well, except for this one, because I don't know what to do there. Linked logic puzzles didn't even occur to me for a logic construction. I'll have to experiment next year. Does mine count as linked? Actually, Procyon, you haven't finished test solving the gift that I gave yet. You should do that sometime, maybe when I'm done with this. Okay, so we have this piece of black here, and we have this piece of black here, and they have to meet up somewhere, right? But they could meet up by just connecting across the edge, or by going through here. So I don't think this is resolvable yet. Let's see if I can do something here, right? If this is white, then that forces this, and this, and this, and this, and this. Okay. Summary, if that is white, that's a 2x2, that's a 2x2, and that's a 2x2, and now we have a checkerboard. So how can this actually be, like, how can you see this? How can I just tell that this can't be white? I'm not sure. But okay, so it just can't be white. So that is black, which means that is white. That's a 2x2 rather. And now this entire black thing has to come out. It has to go down either here or here. If it goes down here, then it would have to do all of these. And if it goes down here, then that is white, and then it would still have to do all of these. So an easier way of saying this is that this line here cannot, you can't have it all be white. So these have to be black just to allow the black to go through. And then, let's see, this. Did I miss a message? I'll do yours, but in the future, that's fine. Yeah, you've been doing MITMH. That wears out anyone. Let's see. We have the purple. Nope, there's nothing else to transfer. That's annoying. Okay, what about... So we know that one of these is black and the other one is not, which means that the only way to disambiguate that is through this. But this is also ambiguous, right? You could absolutely have this, and then that, and then that. But you can also have this, and then this, right? And this isn't even required, right? You could still have this and have it come out here, and that also works. I guess we'll find out at some point. Let's see if this can be black. That forces that, and then that, and then that, and that. That seems to work, and it still doesn't disambiguate these. So what was my hypothesis here? It was this one. What if this is white? That works too. Or does it? Wait a second. If this is white, can this be white? Alright, let's try black first, since I clicked that. No. Let's try white. That has to come out, and that. Yeah, that is definitely possible. All of those are possible. Well, that is annoying, because it means that they're both possible here as well. Penzo, if you find any other deductions, please let me know. So I can see that these can't both be white. One of those is black. But it could just be one of them. And it could be either one of them. And if it is this, then these have to connect somehow, and they can totally connect like this. Except not like this because of that. Maybe I should look at that next. No, I've already looked at that. I know that they can't both be black, but either one of them can be the white one, right? If this is the white one, in fact, they can both be white. And then it just does that. And then I don't even, right, even this is ambiguous because it could be this, or it could be this, or it could be this. These are all possible. You can do a little more in the top left. Well, I've already looked at the top left, so I'm not sure what I can do here. Okay, I tried this. That makes that. Which makes that. And then, obviously, that. Oh yeah, checkerboard. So that. And that. And that. This is not a contradiction. So this is one possibility. And then the alternative is that is white, which makes that black. Is everything connected? Well, yeah. Oh, there are actually three pieces. This whole time I was only paying attention to this connection, but not this connection. Okay, so this was forced by this, right? So that, let me just do that again. That would do this, and do this, and do this. And now this D-shaped thing, or this upside down F shape, is isolated. So one of these has to be black. If it's this one, then that forces this. If it's this one, it has to come out further, and then it forces this. I neglected to, okay, let's take a screenshot of this one and the other one, right? So if this one comes out, then that has to do that, that has to do that, that, and then that. And that is forced, if I'm not mistaken. So this and this, let's put them like this, and let's undo all of this. And now let's see what they have in common. So what they have in common is that and that, and that. Okay, so these two could go either way, but that is on, and these two could go either way. Yeah. Okay, so with that in mind, I now have this here, And let's see if that gives me some kind of contradiction somehow, somewhere. If I do this, I'd get this, and then 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 this, and this has to come out, and then this, and this has to come out, this, and this has to come out, yes, and then these have to connect, but they can connect like this or like this, so that's not actually forced. Yes, it is forced because this piece of white has to come out. And now either one of these could do the connection. Okay, so that was one hypothesis. Let's do this and let's close the other two. The other possibility was, the other possibility is this is white, which makes that happen. And then this, and this, and this. Okay, so already I'm seeing a lot of commonality. So even without that hypothesis, I can already say that, yeah, literally all of the last three columns are required. So that means that this should give me a contradiction if I did this. So what's the contradiction here? Bingo, it's that again. So I need to somehow train myself to be able to see this kind of constellation. And I don't know how to do that. So any one of these three can be used to connect these. And then down here, yeah, they could even be all white. That would make this one white, and then the connection here can be on the bottom, right? But you could also have this, and then that happens, and it's all ambiguous. Great. Okay. So we have. Oh, look at that! They don't even need to connect at all here. The grays, the shaded, because they can connect here, and that still works. What's the next step? Or where is the next step? Let's try this one here. If that is off, then that is on, that is on. And then this white piece has to come out, which forces that. And does this have to come out? No, I don't think so. Right, so it connects either through here or through here. Is this possible? Yes, it can still connect either here or here. Okay, let's close this. Take a screenshot of that. And what was my hypothesis again? This was the hypothesis. So if I do the alternative, which is this, then we need this, and then this, and then this, and this. And this. This piece of white has to come out, this has to come out. I have a funky one on the bottom right if you want. Thank you, I'll come back to you in a sec. Actually, go ahead and write it now so that you only need to press enter when I say so. Okay, I think this is about as far as I can get. All the black is now connected, and the white has to connect through here. It's wrong. Okay, that's unfortunate. So let's take a look at the commonalities between those two. Undo everything again. It was this one here that was the hypothesis. So apparently, yeah, apparently they actually have nothing at all in common. That is amazing. Not a single pixel. Well, Okay. Let's close that then. You said in the bottom right, right? Right. Maybe I shouldn't have closed those two. Let's see what happens if this is black, because then it has to do this, and this white has to come out. And then we actually get two blacks here, which, ooh, I didn't actually pay attention to whether one of the two possibilities I had two whites here, which would, you know, violate that. But let's continue with this for now. Well, the blacks have to connect here, so they cannot connect again. So this all has to be white, which means that all of this is now forced. So this is the only way to solve this if this is a connection. And then this is the transfer. And that doesn't really do much. Okay, so let's compare that to the alternative. Let's put that here, and the alternative is that this is white, in which case they have to connect here somehow. But I don't know where. But also that's white now. Yeah, it seems to me that this possibility does not imply anything. And the annoying thing is the connection doesn't even have to be in those 3 pixels, you know? The connection could be something like this. Okay, not like this. Oh, in fact, yeah, it could just be this. And now all of the black and all of the white is connected, yeah. So you could have something like this. That works. Okay. Oh, that is annoying. So I remember trying, like, having either this black or this black, you know, exit. Oh my gosh, I only just realized that that is not even the case. They could absolutely both be shut off, and this black pixel could just connect with the top edge. And then you could totally have this and this and this and this. And that is valid. Well, okay, it's not valid, but for a different reason. Penzo, help me. I don't know. I am stuck. What if this is white? It makes that white. And it makes that white and that white. But also, more importantly, it makes that black, black, black. And this entire bottom part would be isolated if it didn't come out. And that's basically it. Okay, so that was one hypothesis. the other one is, yeah, so what if this is black? If this is black, then, whoops, then this happens. Which in turn means that this happens and then this happens. But then also, nothing here is required because it could connect either through this or through this and then come out. Could this ever be white? If this is white, then it would require all of this to be white. That is a lot of white. Let's see if that gives us anything. Apparently not. Okay, so if all of this is white, right? Ah, we have this thing again where yeah, so this black thing on the bottom has to come out. So that actually has to connect. And then that places that. Not that it matters, but oh, it does actually do that, but okay. So is there anything else we can do here? So we now know that these can't all be white because then this component here would be isolated, but we don't know if it connects either here or here. If I make this one black, yeah, it's just immediately not possible. So that is white. Also, this can't be black because it makes that black, and then we have a checkerboard. So that's white. And then that's a 2x2. That is, oh, and that is also wrong. Okay, I think I've just proven that this cell is black. But more generally, I think a lot of these you just, like, how far does that deduction go? You know what I mean? Like, okay, let's say this is white. It makes that white. And then we have this connection issue here, which means this black part down here has to come out. And it has to go all the way to here. And now we have an edge contradiction. Bingo. So that is also not white. So that is black. Can this be white? If that is white, let's see. So we no longer have the issue with the connection at the edge, at the right edge, which means that this could actually close up because the black can come out if it wants to. Okay. Now I have a suspicion that this being black will give us a contradiction. So let's try that. If that cell is black, then all of that happens. And now this component here has to join up with something, but nothing else has to. Right? We can do that connection in 3 different places, and then everything else could just be a branch. Really not sure about this. I should go back to this. I just have a feeling about this. So let's put a sub-hypothesis under this, right? What if this is now black? It forces this. Yeah, but it doesn't force anything else. This cannot be white, right? Because... oh, no, it can. This works. Aw. Okay, let's do the other sub-hypothesis, which is this is white, which means this has to come... oh, there we go. That is a contradiction. No, it is not. That is not at all a contradiction. Why did I think I saw a contradiction there? Okay, so this white has to come out, which puts a white there. And I guess I should fill this in as well. And now this entire black component, this entire black component is now isolated. Bingo. So that means this sub-hypothesis is wrong. So that has to be black. So let's do another sub-hypothesis, namely this, because that would force that, and then that, and that has to come out. That has to be white. That is, oh, there we go. Okay, that doesn't work. So that has to be white. And I bet that this is still broken. Yep, and now this left component is isolated again. So this... wait, what was my hypothesis? This was the hypothesis. Therefore, this has to be white. Okay. That makes these white, which is also a contradiction. Therefore, we have now exhaustively proven that this cell has to be black. Okay, let's try the next one. What if, whoops, what if this one is white? So that still happens, that still happens, that still happens. And that still happens, and that, and that, and that. Ooh, everything is happening now. This has to come out. And now this entire component down here would be isolated if this weren't black, so that has to be black, and then this has to come out. So this works, and it would place this down here, and therefore that is black, and then that is white, that is black, and that is white, black, black, black. Black, black, white. Okay, I think that's as far as this goes. Right, but now we have 3 blacks here, which means that we can't have any 2 blacks here. We can have only 1 black here, but that's okay because we've already determined that these can actually all be white, and then this just snakes around like this. And then this just works, right? That, and then that, and then that, and then that, and then, ooh. This does not work. Okay, but that was a massive hypothesis of having them all be green. This is so annoying. What was my hypothesis here? It was this one, right? That was my hypothesis. So what about the competing hypothesis, which is that this is black? I've already tried this. Yeah, I've already tried this. This doesn't, whoops, this doesn't get me anywhere. Do I have any more, nope, any more progress from anyone? Please, speak up if anything jumps out at you. So let's undo this. So this is as much as we know. So what happens if I make this black? If I make this black, it makes that white and nothing else. Never mind. Whew. I'm very surprised that this is supposed to be unique because, you know, it seems that this can go any way, this can go any way, and this one here is completely open. So, you know, we're gonna have to make judicial use of these small things, like the fact that these can't both be black, and what else? That seems to be the only one, really. These also can't both be white, obviously. So there is a black here. But it could connect to the black underneath, or it might not, and we don't know that. I'm sorry, but it seems that this was the most promising. Let me just try this again. If that is all white, right, then this is black, this has to be black, this goes white, that is white, and then we have, wow, everything actually just happens. And this has to come out and connect. That, and that, and that. So, can we find a contradiction here? This has to connect, and then this has to come out. So that is entirely forced from this cell being, no, from this cell being white. That's the hypothesis. So let's keep that in mind, that this is the hypothesis. That has to be white, that has to be black, 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 is white. That is black, white, black. Okay, that is a lot of knock-on effects. I gotta head out, sorry. Okay, thank you very much for keeping us company, Penzo. So, what else can we do? This black has to come out. Can this be black? If that is black, yes, it can. Can this be white? Yes, it can. And then this is completely ambiguous. If I accidentally create a contradiction without noticing it, please point it out to me. I would appreciate that. So let's see, we have the black edge up here, right? So this chunk in the middle here has to connect to it somewhere. Oh, look at this block here. This has to come out. Oh, I didn't see that. And here we go. This is, nope, not a contradiction. Nope, not a contradiction. That actually works, as far as I can tell. If I'm wrong, please let me know. So that actually populates these, which means, did we determine that? Yeah, this cannot be black because it would isolate that T piece. So that is white, which forces both of these, and that has to come out, which makes that white, and that white, and that white, and then these have to connect up. Okay. And now that is forced by a 2x2 rule. That is a checkerboard, that is a 2x2. And now this entire white component has to come out. That goes here, then that is a 2x2. And now everything except for orange is solved. So this is all predicated on this assumption that this is white. Okay, so if I end up with the correct answer here, then I think I'm going to stop the stream. I'm going to stop doing this on stream, but you know, I would still want to know what the actual deduction was. So I think I might actually contact the author of this once they are revealed. Let's find out what we can do here. One of these has to be black, and therefore one of these has to be black. Let's start by examining if both of them can be black, because then you get this and this. And then this white piece has to come out, and that has to happen. This white has to come out. So that puts a white here, which means that is white. That black has to come out. This entire... Oh no, this is all connected. So this, it's enough for this to connect on the left and then here on the left. So let's see, does this... This is already connected, all of this. So this cannot also connect. So that has to be white, which makes that white. And then that is white, that makes it black, white, white, black. This has to, actually this has to come out, there you go. And then this has to connect. This appears to be a valid solution, and this appears to be valid. Oh, damn, it's not giving me the, you know, the pop-up that says, correct. So I don't know if I've just violated something. So let me just very quickly look at each of the black and white regions in each of the sub-puzzles to make sure that they are all connected. And it turns out they are not. Like this F piece here is not connected. So I messed up. Yeah, I messed up there. That is very interesting. Right, when I connected that up there, I thought that this needed to be white, but that is not the case. But everything I did after that is probably still valid. Right, okay, so I did this, right? If this were white, it would form this line through, so it would isolate some black. So this has to do that, and then this white has to come out. And then that forms this, which requires this, 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 this. Okay, there's a lot here. That was wrong. There we go. This black has to come out. Okay. So we still don't know which of the two here is the connecting square, right? It has to be one of them, but it could be either. So this puzzle will have to disambiguate that, and the only way for it to disambiguate it is for these black things here to connect, so that this has to be all white. So I could use a uniqueness argument here, actually. So earlier I said, I think my second sub-hypothesis was, what if these are both blacks? But I just realized that because we have so much black here, maybe I should look here, right? There can't be two blacks here. Wait, didn't I have something there? Didn't I place a black here or something? Or here? Or was that a hypothesis? Maybe it was a hypothesis. Ah, no, I think I ruled this out. If this is a black, it would make another black here and then a white here. And then this, bingo, this is now isolated. So that cannot be black. That is a white. That has to come out now. And that has to be black, that has to be black, that is white. And then I think we can continue similarly. Let's try this. If this is black, that is white, white. Okay, that one is not as clear. What if this is white, and this is black, 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 white. Oh, that is already a contradiction. There you go. Okay, so if this were white, this is black, and then this is impossible. Okay, therefore this is in fact black, which makes that white, and okay. So what about this? This piece, this entire piece here has to come out. So this is actually black. But again, these could connect anywhere. So that's not clear yet. Let's see. Right, but we can't have two blacks. But why would we have two blacks? No. We also can't have it all be whites, because then this cannot be filled. Okay, therefore there is a black somewhere in here, and therefore this cannot also be black. Because if this is, oh no, it can. You could have this. Let's see if that works. Oh, it does not. Okay. So that was, what was the assumption? The assumption was this, right? If this is black, then that is forced. If this is black, then that is forced, and then that is forced, which forces that. And then this is impossible. Okay, so therefore this is not black. Can this be black? If that is black, then nothing here is, nothing follows. But we do know this now. If we put, if we put a black here, it forces quite a lot of things. This one is not forced yet. Oh yes, it is. This even without all this hypothesis, bingo. This component down here has to come up and connect, and then this forces that to happen, which forces that, and then these, and this is now impossible. Okay, what was my last hypothesis? Shit, I forgot. Okay, did not mean to press that. Was this a hypothesis? No, it wasn't. Crap, I don't remember what my hypothesis was. This, was it this? I see. I tried the white here and that didn't work, and then the black created this issue, didn't it? So that had to be this had to be this. Crap, it's very annoying that I'm rather unsure now, but we do know this much because of the blue in the top right. Okay, and then this one here is forced, that's forced, that's forced. That's forced. Yeah, all of this is forced. And that. And that also. Okay, so from this position on, right, we can say that these have to, this has to come out. And then all of this is forced, which places a black here. Which places a black here, obviously. And then this forces that. So then checkerboard happens. The white has to come out here. And then this happens because of the checkerboard here. And then they have to connect. Okay. And then we get this. And that seems to work. Okay, so this white component here has to come out. So this is all forced. This seems to be in one piece. This is in one piece. So my only mistake earlier was this, wasn't it? So I should probably continue with this bit here. Right, we know that one of these has to be black because of this. Sorry, because of the white. So that means one of these is black. And then the big question is, okay, let's say this is black. If this is black, then this would isolate a piece of white. It can't. So the white has to come out, which does a lot up here. It does all of this, and therefore this. And then also this. Interesting, this is still ambiguous. Okay, but we have a white here now, which forces a white here. That black has to come out. It is so amazing that this is unique, you know, that this puzzle has a unique solution. Okay, I think that I am still in only one hypothesis now, right? This one here. Everything else was, or was it? Now I don't remember. But let's just assume that that was the case. If I find a valid solution this way, then that's good enough. So let's place another hypothesis. It seems that that there shouldn't be much left here. So I'm just gonna put something random like here, because that would require this. That has to come out. And oh wait, even before that, even without that, this piece has to connect either here or here. So I should try those two possibilities. If it does this, it could still continue down here. That's annoying. So let's say this is white, because then it has to come out big time. And then oh my gosh, that still doesn't rule stuff out. Okay, so let me just guess. That does that work? That. Ooh, that does not work. Okay. So what was my guess here? My guess was that. Which means it has to come out through here, and then this happens, and then this happens, and now we have a loop, which is also not allowed. Which means that if I haven't made a mistake, this has to be black. Okay, now we have to worry about this piece here. If I make this, white, then we get a checkerboard. Therefore, this is actually black. Okay, if I make this white, then yeah, that is absolutely possible. What about if this is white? Because then that is also white. I thought I right-clicked here. And now that is also not necessarily a contradiction. What about this? That also works. I'm really unsure here. This is so much guesswork. So let's try something that is likely to reach a contradiction. What about if this is black? Then we get white, 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 black. Okay, there we go. Let me try that again. If that is black, then that is a 2x2, and then this is a checkerboard, so that would have to be white, and then there you go. It's just not possible. So that is actually white, which makes that black and that black. Okay. So now the inside of this here has to come out, so this has to be white. It makes that white. And then we have the checkerboard, and then the 2x2 that has to come out, and then this has to connect. Quick check that this is in one piece. Looks like it is. And this one here has to be connected like this. Okay, now, is it all valid? Do I now have a valid solution? If any of you can see a violation, which means either a 2x2 or a piece is not connected, then please speak up now. It looks fine to me. I think that this is correct, or at least that this is a correct answer. I don't know what the correct deductions would have been, but so let's see if I can figure out this one here, the extraction. It doesn't even say. Okay, but each strip is exactly 5 bits. So I'm going to do this in binary. Let's do it like this. So I'm going to do this in rainbow order. So I'm going to start with red, right? And I'm just going to write it in binary, and I'm going to do the conversion. I'm going to automate the conversion. And then we have 1, and then we have 1, 1, and then we have 1, 0, 1. Okay, so now let's just put 0b in front, and then let's just use the, nope, not that, use the text field calculator. And that will give me embrace. That is an English word. No, that is the wrong one. This is the right one. Click that and check the answer, but it's almost certainly, there you go, it's correct. So I didn't solve it properly because, you know, I used a hypothesis, but I used multiple hypotheses really, but whatever. So we have that. So I guess by Penzo's recommendation, I'm going to skip solitary task and I'm going to look at the meta, which I have not seen yet. You've overcome all of my tasks, says the taskmaster, but now you must overcome me. He draws his weapon. En garde! You look back at the tasks you've completed. Considering these episodes in your life, how can you be sure of victory? Alright, let's see. So these are the words. And I see some repeats here. It seems that every emoji occurs exactly twice, if I'm not mistaken. So let's see. Let's put this on the left and this on the right so that I can see what's going on. Let's do this. That was wrong. Oh, it's 5 per row. Okay, yes. Okay, question mark 9, picture frame 12, and there we go. Let's do that, and then we change all of the spaces to tabs. So everything is aligned. So this is a 5 by 5 grid, which is of course, no, it's 5 by 6 even. Yes, it's 5 by 6, which is 30 answers, 30 spaces, and we have 12 answers. So it's not a one-to-one mapping, not an integer mapping. Also, I'm going to close this now. Okay. So since there are 30, and there are 30, oh wait, it's not 30 pairs. I see that the picture frame occurs 3 times. So, well, this is annoying. It doesn't highlight the occurrences. Okay, so that one occurs 3 times. You know what? I'm going to put this in a spreadsheet. I'm going to add. I'm going to call this the meta. I'm going to call this answers. In fact, I'm going to call it feeders. Right, and then the meta puzzle looks like this. Okay, so let's use. Let's see if I do this, what happens? Yeah, it doesn't affect the emojis. There's no real way to make the emojis sort of dimmed out. So I'm going to remove the emojis here. So everything that is not a tab or a digit or a new line. There you go. And then I'm going to use conditional formatting to highlight in gold everything that, so where regex match A1, and then let's put like G1. So this cell up here, G1, is going to be my reference cell. So now if I put this here, so why does that not work? G1, like that. There you go. Okay. So if I put an emoji up here, it will highlight the cells that have that emoji. And then I will just color these. Okay, so let's start with the detective. So let's make those red. Then we have the stethoscope. That's those two. Okay, so that's, maybe, oh, I have another idea. I'm going to, let's do, okay, all of these go away, all of the tabs become new lines, and then let's deduplicate these. So these are all the emojis that actually come up. Okay, and I'm going to write down like how many times each of them comes up. I want to reorder them. I want to reorder them in the order in which they occur for the first time. So we have this guy, and then we have the stethoscope. Wait, actually, no. I've already sorted them by Unicode. So I might as well, you know, it doesn't really matter what I sort them by. So the stethoscope occurs twice, and I will give it this color. The detective occurred 3 times, and we'll get this color. And then let's try this. So that occurs twice, and let's give that this color, I guess. And then let's try the question mark. That is 3 occurrences. And then we have this. That is 2 occurrences. Does it alternate? Like 2, 3, 2, 3, 2, 3? And then this. 1, 2, 3. I'm going to make this pink. And I'm going to make this one here a different color because it's very difficult to distinguish. Let's put that back in. Yeah, it's those 2. Okay, let's make these purple. Like this. Gosh, the purple and the pink are very similar as well. Oh, this is very frustrating. Okay, let's put that here, and that is a 3. And let's now use darker colors. And then we have this guy, that is again a 2. Let's make that one green. The picture frame occurs 3 times. That is blue. Do we have a message? Nope. That is 3. The handshake occurs twice. Let's make that purple. And then we have this guy that occurs twice. Let's make that pink. And then finally, that would be those 3. Yep, it is those 3. Let's make that one gray. Let's make sure I have everything. Yep, I do have everything. Okay. So what do we do with that? Let's delete this conditional formatting again. What do I do with this? And the answers, of course. Do I have the, no. Give me, there we go. So these are the answers. Obviously, these are in no particular order because the puzzles were alphabetized by title. So I wonder if a specific letter that occurs multiple times in, you know, like if there is a letter which occurs like 2 times in some of the answers and 3 times in some of the others, how would I find such a letter? It would have to be one of these if that's the case. And this one here doesn't contain an M or an F or a C. So it would be U, L, or R. This one does not contain a U, L, or R. So that theory is not correct. What is the total length of all of these? 137. That seems a bit... I mean, granted, I don't know the length of the question mark answer, so we'll never know what that answer is. If anyone has any ideas, please let me know. So I think that we need to associate these answers with emojis and that the numbers are indexes. But I can't see any association here. Like none of these have anything to do with detectives or pictures or emojis correspond to sub-puzzle names. The names, I see. It could be the names. Oh, yes, it is going to be the names, isn't it? No, actually cream of the crop, I don't know. So let's see, let's do this. Put them here, make them narrow. What's the agency it was called? I want to get this font, please. Oh, it doesn't have it, of course. Erg. Okay, fine. Fine, have it your way. Let's just do... what's a reasonably narrow font? Droid serif, perhaps? This one here is reasonably... there you go. Let's just do that and make it size 14 and then middle and then right align. Okay, so artistic task could be that. Balancing task, oh, this is perfect. Illumination, yes. Image recognition, okay, this is actually working. So I should probably mark the ones that I already have. Yeah, in fact, I'm just gonna make a second copy of these. So I have that, and that. Prize is obviously that. Turing is about computers. Team, that is a team, I guess. Solitary, that is a solitary person. This is the head of a giraffe, I think, which is a zoological thing. Veterinary means doctor for animals. Reconciliation is a handshake. So, one of these is pointless and one of these is Turing. Not quite sure. I'm gonna go with this, I think. So, let's see. So for each of those, so what is the easiest way to do this? I'm going to, so for each of these cells, I want to find the emoji in this list and then put that number in and then use the rest of this for indexing. So let's actually erase all of this again. I don't need that anymore. So let's see. Equals. Let's see. I'm going to start by splitting these up into the number and the emoji, right? So let x be the regex extract of this text with something at the start, which is the emoji, and then the digits at the end, like that. Except that that needs to be a question mark. So this is the number, okay? And then I'm going to let the emoji, so x should be, whoops. So x should actually be called n for the number, right? And then I'm going to let e for emoji be mid of this from 1 to the length of it minus the length of x. Okay. So let's see if that gives me the correct emoji. No, unknown, oh, x, I renamed it to n, obviously. N, please. Close parenthesis there. Okay, that seems to give me the emojis. Very good. Okay. So the next thing I want to do is I want to do a lookup for that emoji in this range and then obtain the result, which is this. Yeah, and that's that. So this should give me all of the answers. Let's see. Yep, all of the detectives seem to have Daisy. That looks correct. And now I'm going to call that XLOOKUP the answer. So let A be that. And then I can just index into that answer by n, which is the number 1. So I hope I've done this right, and I'm getting okay. So this should have been, oh, Fulcrum does not have 9 letters. So it can't just be indexing. Interesting, but it also can't just be take these in order because we have multiple 2s. What is the largest number that we have? It's a 16. We have multiple 16s, right? And none of these are letters. What is the longest length of these? Okay, so there are some that are 17. Whew. I am not sure what's going on here. But you see what I was trying to do, right? Let's use my favorite answer font. Let's actually bold that. But obviously the letters are not correct. So we've got the answers associated with each. Hang on, we said that. Yeah, no, the answer to that is fulcrum, which is only 7 letters. So how could we get a 9? Is there any more hint? He talks about a weapon on guard. You look back at the task you've completed considering these episodes. Oh, okay, I have to actually look up episodes of Taskmaster, apparently. Okay. Taskmaster. Let's see if Atachyphobia. Nope, that does not seem to connect. Yeah, these results do not mention Atachyphobia. So, okay, let's go to the Taskmaster wiki, because there is a fandom wiki, which is this one here, and see if the artistic task finds me something. Okay, no, it does not. You've overcome all of my tasks, but now you must overcome me. He draws his weapon. Considering these episodes in your life. Well, I cannot determine episode numbers until I know what the tasks are. And if neither the name of the puzzles nor the answers properly hint at one, I mean, fulcrum or lack of confidence, what Taskmaster task is that going to represent? I don't think that's a thing. Oh, maybe it's the other way around. Maybe these are actually episode numbers. Let's get the lengths back. And let's see how many seasons are there. Series. Okay, so there seems to be a series 16, which is quite far. Series 15. Okay, so there is no series 17 yet. In fact, if we look at this here, there we go. There is there is a 17. And will likely air in spring 2024. So it can't be that. So these cannot be season numbers. Well, let's not do that. I suppose they could be episodes. Could they all be from the first season or something? Let's go to season 1. Where's the list of episodes? Okay, so season 1, episode 4. Completely empty this bathtub. You must not remove the plug. Oh wait, this is... Yeah, this is episode 1. Okay, episode 4 has these tasks in it. And it says prize, but prize. But all of them have prize and team. So I'm not quite sure what's going on here. I'm gonna need a hint on this. And since Penzo's not here anymore, I'm going to need to either wait for him to respond with a hint, or I'm going to ask the author. In both cases, I guess it feels a bit annoying to stop the stream here because you were probably hoping to see the end of this, but I am not seeing it, and I want a hint. So I with a heavy heart, I think I have to close down the stream here. And I guess I will see you guys again the next time I stream something. But yeah, I suppose I can start the next stream with the rest of this and then do some other puzzles on the other stream. But for now, I'm going to stop the stream here. I'm getting hungry as well, and it's 11 o'clock. So thank you all for watching. It was a great honor to stream for you today. Thank you all for your for your help, for your input, for your comments. And I will see you again another time when it is time for puzzles on Tim Weed's channel. Goodbye.